Let's get started. Yo, welcome. Today, I think I want to work a little bit more on the pipelines to fix the streaming stuff and the just being able to use functions in pipelines and all that good stuff. So basically, yeah, kind of like the heart of the language, so to speak. So that's what I'm trying to get at today. Hello, Blue. What's up? Welcome back. How you doing? Yo, Polaris. Welcome. Yeah, so I think what we need, like the pipelines, like if I bring up the MVP here thing, so basically the pipelines, what it is, a list of pipeline stages. Yeah, I don't know, Blue. Maybe. That's why I'm like not doing much today. I'm just I had some time over, so I just thought that hey, I could stream a little bit. I think it's just because it's early in the morning as well. It sounds maybe worse than it is. So basically a pipeline, you have a list of stages. Each like stage is one of these. But basically I want to generalize, or I want to kind of put this into a pattern. So basically, you know, because the potentially this could just be a function. Let's say we have a function, you know, usual function here that produces a string, let's say, and we echo hello. Okay, so that's a function. Now, you should be able to use this function and piping it into a get, right? Which does work now, but it's kind of like each component is like this own thing. Like the function is a function, of course. This is a executable, but really they should be the same thing. Like really they should be kind of treated as the same kind of thing, and then we can just, you know, pipe things willy-nilly however we want, which also goes for expressions. So hello string, and that is also something that you can pipe from, and when you do it, it actually like creates a stream. Like we somehow turn this thing into a stream, right? And then we put it forward in this pipeline, right? That's what's happening. And then each of these, actually there is a slight difference in the first one and then the subsequent one, because the first one can only have an output, right? It can't really have an input, or it could have an optional input, let's say. But the rest of the ones, they need to be able to have, you know, both inputs and outputs. So yeah, so that is kind of like how I'm thinking about this. So basically I want to be able to turn basically anything that we can use like this into some kind of stream producer. I might be seeing where I'm going with this, but a stream producer that, so each time you're using this in a pipeline, it actually, you produce also a stream. So what I'm thinking is the observable pattern, like I talked about yesterday, because to me this really seems like an observable pattern, because you're kind of subscribing to hello and you're forwarding the results into something that is the cat observer, like an executable observable that takes arguments and an input stream. and it put out, and you create a new stream that you output to something else. So basically, if we look at these pipeline stages, they don't necessarily need to be, you know, executed all at once. You could treat this as a binary expression here. This could be a binary, because it makes more sense in my head than having to, like, you know, have this kind of list, and then you spawn up everything in and you pipe this into this, pipe this into this, pipe this into it. Like, that doesn't, like, sure, it makes sense in a way, but also this also makes sense. Like, if you treat this as binary expressions, this is gonna get grouped like this. So we'll have, whoops, first one, well, no, wait, how is this gonna be? No. So first one is the most inner one there, or the so this one is gonna be the first one that gets, like, evaluated. And when it gets evaluated, basically gonna take this, turn it into a stream, pipe the stream into this, which, you know, takes a standard in, arguments, it's an executable, it takes a standard in, arguments, it's like a function, really. So it takes standard in, arguments, and then produces another stream. So basically, the things you can have at the start are gonna be values that can be turned into strings, or streams of strings. Or if you're piping into, let's say you pipe to a function that requires something else. It depends on the standard in type over here, actually. But let's start with the simple thing first. So the first item is always going to be, well, it kind of has to be a stream, right? This first item has to be a stream. However, this is not really a stream, it's a function. So we have to coerce it into a stream, which means we just call it and you get the stream, basically. And then we pipe the stream into cat, which is a function. So we basically just provide, when you call a function, you have to provide standard in and arguments, and then you get a stream out here. So now this expression is also a stream. And then we just repeat the process. So this stream gets piped into here, which does the same thing, and then this stream gets piped into here, and so on. So that's kind of how I'm thinking about this. This is going to be a binary expression, not like we have it right now, where a whole pipeline is, you know, evaluated into a list of things. It's actually going to be like a binary thing, because then it kind of fits within the other patterns in the language as well, and yeah, it just makes sense to me. Okay, so how do we achieve this? Well, first, I think I might just abandon the whole thing we already have with the run pipeline thing. I'm just gonna make a new binary operation, which is this pipe here. I'm gonna change this to be a binary, and then yeah, this is gonna be a new binary expression, and then the binary, and then we evaluate it in the binary sort of expression handler, basically. So let's start with that. We can think about how we can deal with this. So basically, also another thing with this is that I really want to have executables, because being like explicitly defined. However, I don't want to do that right now. So what I'm gonna do is basically, maybe in the semantic analysis we could kind of provide more information to the expressions, perhaps. Now, the expressions are usually like constants though, so we can't really change them after the fact. But I guess we could just try to change that. Like, well, actually they are not They no, it's the type expressions that are constant, not the normal expressions. So we could potentially say that, hey, this identifier expression, because we're not gonna parse it as a pipeline anymore. We're gonna parse it as a binary expression, and this binary expression here, or this binary like component, is just an identifier. It's not gonna be parsed as a pipeline anymore, which really helps a lot with the whole thing. We're not even gonna have a pipeline parser anymore in the parser. So let's go to parse binary. Now we have these binary operation. So here's all the binary operations: add, subtract, multiply, divide, remainder, greater, less, equal. So all the usual stuff. Now we want to have pipe, which, you know, it just pipes. Maybe we should do this: pipes standard out, or I mean, yeah, it actually standard out doesn't really matter. Actually, it just pipes a stream into a function that takes the same type. So basically the left part, so this is gonna be a stream of t, and then we pipe into a function that takes t as standard in and then produces something else as standard out, and then the whole type of this will be a stream of u now. And then we also have potential like arguments here as well. Some kind of arguments. Okay. And then, you know, and then we can add, you know, the redirections, like, you know, because there's also going to be this innate notion of having standard, I guess, 2 streams out, where we always select standard out as like the usual stream that we get out. But really, a function actually has 2 outputs. That it's kind of weird how that works. I mean, maybe we should just force standard to be strings, and it's kind of implicit, so you can't really define, you know, 1 to be u and 2 to be something else. You know, it doesn't really make sense. I think what makes more sense maybe is if excuse me. And then we also have the exit code as well. So but the exit code is kind of embedded into the output type. So the exit code could kind of be thought of as one item in the stream, and once you have an error, the stream ends, but the last item produced is the error. So, you know, you have potentially an error, and that's going to be kind of like this is like the exit code of the function. But the standarder is still in there. Standarder is still being able to live like behind the scenes here. I don't really know what to do with standarder. I think we just say that it's just gonna be, right now it's just gonna be implicitly a string that gets outputted to the console, basically, unless you capture it. But it's just gonna be this implicit stream that's always in the background, I think. It's like you have to figure out, okay, what other utility could we have with it, but really that should just be the thing. Like for normal executables, it makes total sense, but for functions, it's like, okay, well, we could make it into like a typed standard error stream, but does it make sense, you know? Yeah, but as I said, like the exit codes are kind of embedded into the type here. So you would have like an error type and the output. Well, actually, this would be a stream. Man, okay, maybe the stream has an error type embedded in it. Like this. I was thinking something like this. Yeah, the output is, okay, sure. We call this function with, you know, the standard in, this stream getting put into standard in here. Have optional like arguments here. And then the output is going to be the stream. And then potentially, if you have a, you know, an error in the thing, it's going to be the exit code and the stream will end. And so this is actually going to be E now. E, like this. EU. And let's say you have like E1 going into this. Now you could pipe a type of E1T, I guess, into a function that only takes the T part, because in a pipeline, when you get the error, the whole thing will, it's kind of like a monad. It's kind of like the either monad, I guess. Like as soon as you get a left type, like as soon as you get the error type, everything becomes an error. But as long as you have a value, it's gonna continue the expression. So this is kind of like the either monad in Haskell, or, you know, functional programming. And then this would kind of be like, you know, bind T into the next stream. Yeah. Actually, yeah. So this is like a monadic value. This is a bind function that takes one. No, it's not. Actually, it's not. It doesn't take one. It takes a stream. Oh, I've done this wrong, actually. This takes a stream of T. Yeah. It takes a stream of, a stream of T. Yeah. So, okay. Or you can say that it's kind of like, you know, a monad that can fail, basically. A monad with failure. So if you have this monadic value, it could either be, you know, a valid stream, or it could have failed. And if you pipe something that has failed into something else, you will just get the failed value out. And also, depending on kind of the context, maybe we just exit the whole program with that failure. Or if you want to store the error, you have to do something else. Because I think the normal behavior will be like, if this fails, we're just going to exit the program with this exit code, with the error here. But you could have things like, you know, catch and stuff like that. But yeah, just to be on the safe side, I'm just treating it as a kind of like a monad that can fail here. So then when it gets put into this, it's not a bind function. It's actually just a, I guess it's like a map. It's like a map, functor map. Hello, Penguin. It takes this, and then it has and then it takes like arguments and the monadic like value, and then it has a function body, and it produces a new stream. Man, what would actually... Maybe I'm messing myself up by thinking in functional terms here. But I'm just trying to map this in my head to some kind of functional construct, because it feels like it's easier to reason about these higher level things. I don't know. Anyway, yeah, but basically this gets turned into a stream of t's, because if this fails, then this whole thing fails as well. And then this produces EU. Now this, what I was going with this new expression here is that now we have two types of errors. We have this error and we have this error. So the whole result of this thing is gonna be like error 1 or error 2. And then also, like, let's say you have stream error 1 or error 2 and a U, and then you do like, or, you know, in bash you have like this or, which will kind of it's kind of like catch, except you don't get the error, you just throw away the error. So it's kind of like saying catch something else, do something else, right? So basically this, the type of this will be, I mean, I guess it would be either an E1. Wait, is that correct? So we have this somewhere at least. Or U. No, because E1 and E2 gets thrown away. So it's either gonna be U, but we don't have sum types in this. So really this expression has to produce a U at this point. Unless we, maybe if we discard the value, it doesn't do anything, maybe. I don't know. Or if it's like a void. Yeah. But yeah, I think... But this is a stream of views, though. Yeah, I think it has to be a stream. So this is basically a stream that sort of can't fail, maybe? I don't know. Perhaps, yeah. Anyway, it's just a bit of scouting here. But I think it makes a lot of sense to make the pipe into a binary expression, because it just makes sense. And then we can like reuse the concept over and over, and we can have other things like, you know, the captures, redirections, and we're working with this this common construct, which is the stream or a function. So basically the first item always, the left hand side has to be a stream, right hand side has to be a function that takes a stream. It can't be anything else, I don't think. Okay, so what would be the precedence? It would probably be higher than this. So we have logical and or. It would probably sit somewhere, maybe even after equality. Yeah, it doesn't make sense to have equalities in there. Actually, maybe this should be like the highest one. Does that make sense? No, wait, what am I saying? It doesn't really matter. Like what kind of binary operations would you have in here that would kind of contend with the pipes? I think it's better if the pipes, or like, let's say, could you have like a stream of, let's say you have a stream of floats plus another stream of floats. Let's say we're just toying with if we want to support this expression here. Okay. But then let's say you don't have a stream of floats. Let's say you have a stream of strings, but then you parse float and turn it into floats, and then you add floats. So this would make sense, right? So you would have this pipeline, and then you add this, right? So this would have a higher binding than this. So lower precedence. No. This would have lower precedence, yes. So basically it should have like the highest precedence. Almost, right? Let's just say 50 here. And we can just change it later if it becomes an issue. Okay. I'm not gonna do like redirections now. I think this is the way we wanna go, so I'm gonna start here. And we'll figure it out. It's nice that when type checks in your own language is distracting your workflow. Okay, so binary, well, we need a parser first for it, so whoops. Hello, Oxeth and Discordianism, welcome. Welcome to the stream. How are you guys doing? Yeah, this is like the inner part. We have, this is the one that actually parses like all the components. Identifier. We add that. And then this is like arguments. No, wait. Oh, wait, I just realized something. This kind of changes the whole parsing of the binary expression, because function application is kind of also a binary operation, except it doesn't have a token. I mean, okay, the token is white space, I guess. But if we introduce white space now, it's gonna be, you know, I've just skipped over white spaces. White space, except for new lines. New lines are the only tokens that exist. If we introduce white space now, maybe we have to. Or we could just, I mean, we kind of know it's there, I guess. Like the problem here before is like that, well, in a binary expression right now, we're kind of forcing everything to be some kind of token, like identifier or literal, or parentheses, and then an operator, and then, you know, the next identifier or parentheses or whatever. But we don't allow for expressions like this, like echo, hello, cat. Like this wouldn't work right now because it expects an operator after hello. But this is a binary expression. It should parse this as a binary expression. So how would we go about doing this now? Because, you know, let's say in Haskell, there's a function application operator called, well, I don't know what it's called actually, but it's like an apply. So basically this is like, yeah, this is the left hand side is the function, right hand side is the argument. It also serves another purpose, which is precedence, but I'm just trying to illustrate a point here. It's like now this could be parsed as a binary expression, right? So this would be one binary expression, and then you take this, and now we have like two binary expressions, right? Yeah. Just keep in mind, Discordians, that I haven't fixed up like the AI slop, because this project was kind of jump started with an experiment with AI to try and create something, but I took over after a while because the AI couldn't handle it basically. So now I'm just doing everything myself, which is a lot more fun, I have to say. and yeah. But I will say also, like, I've done the initial part so many times, so it's nice that to also start from, you know, for a change, you know, this is the first time I've done that, like to start from some kind of plateau there. All right, you're learning Zig, awesome. Do you know any other languages, or is it your first language, or is it your first low-level language? But how could we... I guess we can try parsing. We can do a try parse function application, like a try parse function call. We could add a function call or parser that will act as one of these. Like if we encounter an identifier or parentheses, like parentheses is easy, that's already solved basically because we just parse an expression. The literals is just numbers or booleans, or we have a string. So I guess the identifier would be the only thing we need to worry about. If we encounter an identifier, we wanna try to parse a function call. We don't really have that right now because we have parse pipeline, which kind of embeds this behavior. But okay, let's start with a function call parser. Come from high-level language, scripting language like JS and Python. Try to learn Rust first, but it just doesn't go logic in my brain now. And with Zig, I feel I can read the code and make sense. I feel you. I also tried Rust, and I failed horribly. Probably because I didn't read about any of how you're supposed to adhere to the rules of Rust. I just tried to make like a web server just a basic web server. I mean, just the, you know, the tutorial, and I failed because I didn't understand, you know, I got yelled at by the compiler, and I didn't know how to fix it, basically. So, and that's the first language that basically, it felt very harsh. No, I don't know. It probably, you know, it has its good reasons for it, and maybe I'll learn it someday, but I don't know. I've heard that it's like you can be challenging to be productive in Rust, and I like being productive right now. And well, I love Zig. I will say that Zig is like my favorite language right now. I mean, it's not the language fault. I'm not saying that. I'm saying like, well, for me personally, I went in maybe, I should have maybe studied the rules a little bit, but I feel like it's kind of the, well, maybe Haskell also was kind of the same thing, but Haskell was, it felt like I was more motivated to learn that at the time. Anyway, Zig is amazing, so I'm focusing on Zig right now. All right, parse function call. Other way around here, comes to Zig from Rust. It takes a while to get into Rust flow, but once you overcome the initial hurdles, it's smooth sailing. Okay, yeah, I believe that. It was just something with the, like, I know about, because I know Haskell, so I know about, you know, the traits is very familiar because those are basically type classes. But then I think it has something to do with the borrow checker or some kind of, you know, the async stuff. I just didn't understand what I was doing wrong, and I didn't understand the compiler error messages and how to fix them. So I just gave up, basically. But yeah, you know, if I read more about how you do certain things, then I could probably, you know, try it again. But I don't really have any motivation to do that right now because I'm all in Zig right now. Yeah, Zig is just something else. Yeah, I don't know what it is. It just feels like you can do anything, and you don't get like, you don't get stopped. Except for a bunch of memory issues, but you know, that's over. You can overcome that. Like getting segfaults and I just put a bunch of debug logs everywhere so I can find the issues. Okay. Yeah, so let's see. So this would be the parser, which in this file is self. And I think that's it. And we have parse error. Oh yeah, I renamed it, right. It's just called error now, just like in every other file. And then yeah, we don't really have this expression. I think I'm gonna add this expression actually, or the thing about function calls, yeah, I guess if we only have an identifier, it's kind of like a function call. It's like a hidden function call. That's the issue right now. Like in the language, like if you have an expression like this, you have a function hello. That's not a real signature, but I'm just doing for demonstrational purpose. And then you have like a statement that just says hello. Like this is just an identifier, right? But it's actually a function call as well. So it's the same in Bash if you call, you know, ls. It's the same thing. This is a function call. But you kind of only know if it's a function call if you know that this is a function that you're stating here. It could also be, I mean, I guess in the context of bash, you always try to run a command. So in there, it kind of makes sense. But in this language, you could potentially put, like, if you have a, like, okay, I can demonstrate it right now. So if you have a variable like this, right? If you run this right now, well, let's do it here. Then nothing gets outputted. But if I just put s here, it's gonna get outputted here. So, but this is not really a function call, although you could kind of call it a function. It's like a function with no arguments. Yeah, I mean, okay, we can actually turn it into a function call, actually. We could kind of, you know, think about it as an action call or function call, because you can do whatever you can do with a function that doesn't take an input. You can actually use with this. You can pipe it into cat, for example, and that still produces hello world. So that's the idea. So basically, okay, well, I guess we could say it's a function call because we're kind of turning it into a function. Yeah. Okay, sure. All right, so a function call is basically we're gonna peek on next, and we're gonna switch on the tag, and we're gonna say if it's an identifier, we basically have a function call. So we know now we have a function call. So from here, we want to parse. It could also be, I guess we could have a parentheses as well. I guess any expression really would then be a function call. It's kind of weird, because if you have like s, this is also a function call. Because the reason is like any expression that gets you know, put out and it's like on its own like this. The value gets kind of used as a result of a function call. So basically this is everything. Every expression is a function call. So could you say that this is a functional bash programming language now? It's like we can turn every expression into a function basically, and when we state it, we call it. And yeah, it makes sense because that is the main component of the language, the function. That's how it is. Like files or functions, everything is executables or functions. Everything is a function. Yeah. It's like, yeah, that's how it is. And then, you know, yeah. Okay. So, well, right. How, so I'm just seeing like, okay, well, if we can turn everything to a function, couldn't we just, like at what stage do we do the kind of converting process? Because if we go to the AST right now, you know, you have things like literals, which, you know, of course, it's just a number or something, you know. But everything can be converted to a function. So this would just be a function, takes no arguments, returns the literal. So it could be, this is just a function that takes nothing input. It takes, I'm just going to say at for the name there. And then it takes no arguments. And the output is going to be the integer. Actually, I guess it's always, is it always a stream? That's also the thing that I'm struggling with. Should it always be a stream, the output of things? Should you always consider this to be a stream? Because then it could just implicitly be a stream, maybe. We don't have to say stream everywhere. We know it's a stream. Unless we have a void, I guess we don't really have anything. No, we could make the distinction, maybe. But then this could be turned into a stream. So that's the thing. Like you could always turn this into a stream. If you connect this to a thing that requires a stream of ints, we could just coerce it into a stream. So that's fine. But this is basically what this would be in the function form. And then you just have the, you know, whatever literal value you have here. That's the expression. So this is the whole function here. This is turned into this. So everything is a function, basically. And then once we have everything in a function, we can now generically, more easily, you know, talk about, like, use them together and talk about them. Perhaps. That's the whole premise here. It's like being able to more, like, generically talk about these things. I'm trying to find like the most generic construct that we can use through, I guess, throughout the whole thing. And the function is really the main character in that situation. I'm just gonna refill my coffee and I'll be right back. Okay. Yeah, I'm just thinking about, like, okay, well, at which stage does it make sense to like turn everything into functions? Maybe we should start at like the, you know, maybe we should keep the AST as it is, and then when we do kind of the maybe it's good to have it at the semantic analysis stage as well. I'm not sure, but it really would help in the execution phase. That's really where this could be generalized and used properly, I think. All right. But yeah, anyway, the function call. So basically, anytime we have an identifier, I guess we have a function call. So this would return expression, and we don't really have a function call. Well, we do have this, but it's not used right now. This is like remnants of the AI slop here. And we have some sort of expression. That does make sense. I guess the function call is kind of like a binary expression as well. Except we're only dealing with a bunch of expressions that are space separated, or yeah, they're just separated by. So basically, I think the function call is just gonna be, first we're looking for an identifier or parentheses, and then we're looking for any expression that is not like a terminator in a list. Yeah, and that would be our call arguments label. Why would we need we don't have labels. I'm just gonna delete this. I don't know what they thought would happen there. I mean, you're not gonna be able to say, like, you know, let's say you have a function that takes, you know, 2 arguments, and then you later call it. You're not gonna be able to say, like, you know, I don't know, in is or s is hello, and then leave this one. Maybe this is optional. This is not possible. Well, I mean, I guess we could make it into the language, but I don't know. I just don't see it as a high priority right now. Anyway, let's just do this like this now. So we have the expression is the callee, so that makes sense. Because remember, anything can be a function, so this could be anything. Okay, and then we have the arguments. And then the semantic analysis would have to check, like, okay, what's the type of expression? Does it have arguments? And then we can catch this in the semantics to see. And then we have the span. Also, a call expression, it's kind of like, it's interesting now because, you know, if we have, let's say we have this expression, some kind of string gets piped into cat, let's say. Very simple, just to demonstrate the purpose here, or demonstrate the example. Or my thought here. So we have this thing. This is turned into a function call, right? So this would be the callee, the function. And what should it produce? Well, it could produce a string. It could also be, but this requires like a stream of strings, right? And it could be coerced into that. So that's fine. Now, but the issue is here, really. The issue is here, like this is also like a function call, right? But this is a binary operation though. So the right hand side of the thing is really a function call, but with an additional secret parameter, which is the standard in. That comes from here. But this would only make sense in like a binary. So what I'm getting at, let's say you have like a more complex expression here that calls a function that maybe returns, I don't know, it returns what about a function that returns another function? It would have to work out in some way anyway. But this would pipe it in there. But this is kind of like a different function call now. So that's what I'm trying to get at. Like what if you had like another string and then into cat, right? So what is this? Again, we have the string turned into a stream of strings piped into cat. This is now called with the context of having a standard in here. Put in here, right? And so this will produce a stream of something. So this doesn't really make sense. Like this is a stream. It's not a, well, it could be turned into a function that takes nothing and returns the stream, but it doesn't make sense for it to actually receive standard in. So I guess this doesn't really make sense. I guess it only makes sense if this expression returns a function that takes something, that takes standard in, right? That's the key. It's a function that has to take standard in. Right now it's not. It's already set up. Like this is put in here. There's no slot for standard in. So it's gonna be, it's not gonna be able to take standard in. So this will fail in like the semantic analysis with type checks. But potentially you could say like make string function, which would return a function that we can then pipe into. Like it could return a function that takes standard in and puts out standard. Yeah. I was just thinking like in the context of the call expression, we also might have some kind of implicit, or well, in the context of this alone expression, we don't really know where standard in comes from, but we have so we have the binary expression of the pipe operator, and only in that context we can think about the standard in being passed here. So like if you would call make string function right here, if we just produce the function, and it would fail because it doesn't take anything, it doesn't get anything. Unless it could be both. It could be, I guess it could be both. It could be like an optional. It takes an optional stream, perhaps. Okay, but I'm just thinking like in the context of this call expression, we don't really know if it has a standard in. Do we need to bring this into? No, that's gonna be, so I think it's gonna be part of the pipe operator, the binary operation. That is gonna carry the standard in. We don't have it here. We just have it in the pipe binary expression. Yeah. So this is just gonna be the a call, and then only like together with the pipe operation, we would know the full story basically. Okay. So we don't need to add any standard in here, I don't think. Because that's, no, we don't. That's already part of the pipe expression. Yeah. So what is the call argument? It's basically expression and span. But expression already has span. So we don't really need this to be an argument. This is just going to be an expression. Oh, I just realized something. It maybe makes sense to make the functions curried? Question mark? I don't know. Okay, what would the type be? Well, we'll figure it out later, I guess. Actually, the type is kind of interesting because we need to convert this to a function first. We need to kind of convert this into a function type. And they get like the result out. No. Wait, yes. Wait, no. Wait, yes. So if it's a function, we have to kind of take, it's gonna be like the result of the function maybe. Yeah. But if it's something else, it's just gonna be that thing. And then basically what we can do is have a function, have a thing that takes any expression, turns it into a function. If it's already a function, it won't turn it into a function. All the literals will turn into function, and then it could just say, hey, it's going to be the result of this function. But we don't have that right now. So, but this is basically going to be turn expression into function, or already function, return type of function. Yeah. Okay. Is this used anywhere? I don't think so. No. Is this used anywhere? No. Okay. Okay. So we have the identifier. I think now what we do is we could either parse, like if this is curried, you can parse like a binary expression of function application. But I think I'm just gonna parse a list of expressions. So first we do so we take the next token. We know it's an identifier, and we will get the arguments by saying parse list, and the limiter is a comma. The parser is just parse expression, really. Oh shit, I just realized something. What if we get another function call? Yeah, that doesn't work. Yo, dumb guy. Yes. Or no. Like, I know it's a name in... it's my fake name, you know. I know it's a name in India. It's a usual name in... or I don't know if it's usual, but... I had an Indian... a person from India that... came in and thought that I was from India because of the name, but I'm not. I'm from Sweden. Yeah. I think I knew that, but it didn't register to me at the time when I chose it. Are you from India? Let's see. Okay, so we're parsing that. We have options. Now, in options, we can add terminators. However, the terminators now only have like a list of tags. I want to add the ability to say it's a it could be a function as well. So I'm gonna do union enum, and this would be a list, or yeah, whatever. And then we have a function, which is a function that takes token tag traceable. Okay, so it could either be a function or a list now. So let's say this is a function, and the function is gonna be is expression terminator. Oh. Let's do this. The default value is list with nothing. I guess we could have it optional as well, but nah. Or actually, maybe, yeah, maybe this is optional and then the default is null instead. Even though it's kind of the same thing, but yeah, so now we have to support that, so we're gonna do a switch on terminate. Actually, we need to if it first now. If we have it, and we switch on that, and if we have a list, we do this. But now we also need to support the function. If we have a function, so we write a compiler for the thing. Probably not. I don't know. Like, it's just a toy language right now, and I'm just making it. I'm just making an interpreter, so I can write my own like bash-like scripts with my language. Is Zig good? I feel like Zig is Java for C developer. What? Java? Really? I wouldn't call it Java. I mean, there's no classes. I mean, I guess I kind of see what you mean, but I would just say it's like a more modern C and a new take on things. I mean, it tries to keep it simple, and it has, you know, it's low level and everything. It doesn't have garbage collection. It's manual memory management. You deal with pointers and, you know, low level stuff. But then it also has a bunch of nice features that you probably wish existed in C as well. So I don't know. I just see it as like a modern low level language, basically, like a modern C. Zig looks more easy than Rust. I think I will agree with you there, since I tried Rust and I failed horribly, and Zig has just it just makes sense. Zig makes sense to me. Nothing against Rust, you know, but for me personally, I haven't really got the motivation to try it seriously, so I can't really compare though. But I'm just saying my journey was like, I tried Rust, I failed, and now I tried Zig, and it's amazing. Well, okay. You know, if you're not used to the syntax, or if you don't know, like, what kind of programming background do you have? Yeah, this is one of the unique things here. This is like a capture. So it's basically, you know, we have a switch here, and these are the cases. But we're also, like, the type we're switching on is a union, a tagged union. And this is one of the tags. This is one of the switch cases. So we're now, so this terminator can either be a list of something, and if it's a list, this case will be true here, and you will capture the inner part. So you use JavaScript. Okay, so I'm trying to think about the equivalent here. I mean, JavaScript is my day job, so I should be able to do this. I'm just trying to think of an example here. So basically, maybe I've been too much into Zig lately, actually. But no. Well, are you into TypeScript? Dumb guy codes. It's really not that complicated. It's just that, you know, the syntax is, you know, kind of unique in Zig. So basically, well, if you had TypeScript, let's say, I mean, this is kind of like checking what type terminator is. So this is kind of like, you know, if type of terminators equals triple equals you know, object or whatever, or yeah, if it's a function, we will treat it as a function, we call it, you know, else if. But here it's kind of different because TypeScript is slower than JS. All fangs switched to back. Okay, well, I still use TypeScript. Like where I work, we still use TypeScript. I think TypeScript is superior. Sorry. No, but okay. I understand the reasoning behind using JS instead. Even if you are familiar with TypeScript, I don't know. I just feel like I just like the safety of TypeScript. Yes, I am a web dev, like in my day job. I don't know, I just can't do JavaScript. Like, I want my type safety. I know you can use like documentation, like you can have types in the documentation, and that helps, but it still doesn't really replace what TypeScript is doing to me, personally. I know that people enjoy doing it, but not me personally. It's one thing that is nice about it is that you don't have to deal with the tool chain of like the TypeScript stuff. But really, it's not that big of a deal to me. Like I don't really think it's that big of a deal. Okay. Well, this is basically okay. If terminates a function, we get the function out. That's how you would think about this. So it's not really complicated, really. And now we can just call the function. So basically, if function tag, then actually, you know what? Let's just make this into a convenience function here. Is terminator and boom, and they will switch on self if we are a list. Yeah, so basically now we can just capture everything going on in here, go back, put it in here, right, and this would be the tag, and instead of doing this, we will return true, or we can simply return this actually. Oops. Wait. So I'll just do that. And then the function, we can just return the call. There we go. And then here we can add return. There you go. Simple, simple, simple. 1 second. Yeah, I just have to give a friend something here at the door. I'll be right back. All right. How many years of experience? Well, I have 10 years of professional experience, and then I started learning programming 20 years before that, which it makes me feel incredibly old. But yeah, I started learning when I was young, like maybe like 9 or 10 years old or something like that. But you know, it didn't really went anywhere. But I did do stuff and learn. You know, so I was self-taught in C++, and but it didn't really, you know, I didn't really create a bunch of stuff. I was just learning, you know. But you know, I kept the interest with me throughout the whole thing. So yeah, I'm 30 plus. Awesome, Penguin. And you can imagine without using a debugger and using like Windows original Notepad. That's how I started out. I don't even remember the compiler I used. Yeah, man, it was crazy. I could do anything at all, actually. Okay, so now we don't need to switch. We can just say if we have terminators, we can call isTerminator on start tag. And if that's true, we will do whatever we had, which I now deleted, so which is this part here. All right, then we just return empty there. Okay, and then URL list. Let's make this a little bit more convenient to create as well. So I'm gonna make Actually, let's call these underscore, and then you will be function, and we will create this, and we'll pass in, whoops, this function here. Yeah, this could be called that. Yes. And then we just return function is function. Oh, I'm recording a macro. That's why I was like, mate, it's very slow. Wait, why is that not? I was trying to be fancy there, but does it really not? No, it has to. Oh, it's just because of the G. So if I did this, function list G, yeah, that works. Okay. Except the type is not correct. All right. Oh, that. Is wrong, and do that. All right, so now you are a list. You are a function like this. It's just, I just like these, the initialized functions when you have a union enum and you just have a convenient, because it's so annoying to have to type like dot brace and then the thing. It's so much nicer to do that. Okay. No AI. Well, I occasionally use AI nowadays because I feel like I need to keep up with the times, you know. So it doesn't hurt to learn, you know, what AI can do for you, basically, which could be you know, a bunch of stuff. How about compiler optimization, Zig? How about LTO optimization? I'm not sure if I know what that is right now, or I don't recognize it right now. Compiler optimization, Zig, like, do you mean for like the actual Zig language compiler? Like, it used to use the LLVM backend, but now it's they're switching to their own. What's your advice for a fresher? Just keep learning, keep doing like if you're, yeah, just keep doing projects that you can potentially then show that what you've done, because then you have like receipts of what you've done. So if you want to get hired, basically you have a portfolio, you can show like what you're capable, like what you've built, basically. Just keep on working on that, because if you don't, it's gonna be harder. Like it will just help you get better, and it will, you know, also provide you with things you can show to employers. Build.zig is so complicated than CMake. I like it. I don't know. Once you learn it, it's you know, the kind of things you have to learn a couple of things, and then it just it makes sense. But yeah, it is complicated and I guess that's why it's because it's like in Zig. You have to do it in zig-like, but I really think it's cool. It gives you a lot of potential. No, yeah. Do you guys solve problems on lead code? I used to do those kind of things, but I don't do it anymore. I don't know. I just like building projects now instead. Like, it was kind of interesting, you know. Some of the usual issue there for me is like the usual problems on, like, I don't know, code katas and, you know, those kind of programming puzzles. They are not usual, you know, programming things that you would solve in the job or in, like, you know, real world problems. They are not real world problems. They are basically just a puzzle, but they can be fun. Yeah. Okay, well, if they ask it in the interview, they don't really know how to find good programmers, I would say. But okay, I guess there is a point maybe in doing it. You know, if you encounter employers everywhere that ask those questions, if you just want to get your foot in the door, let's say, I guess you could do that. But I would suggest building projects as well. I mean, yeah, okay. I think Micro Funk TV, I think it depends on the actual task itself and how they evaluate your solution and everything. Because you can fail but still show that you are a competent, you know, or that you know that you are smart, and, you know, depending on your reasoning, maybe you didn't have enough time to solve it, but you still had the correct reasoning, or that you know anything, basically, I guess. I don't think you're dumb. You know, it's, yeah, I think anyone can learn programming. It's just a matter of interest. It's the same with everything. It's the same with maths. You know, any profession. It's just a matter of interest, I think. We cannot do like the set the rules. Alright. Okay, so now we have this. Where are we actually? I was trying to parse a list of function arguments, I think. Yeah. Okay, and then the issue is like, okay, well, we can parse a list, but the thing is that the next expression, if that's also a function call, it's gonna consume all the arguments before this could. Now in Haskell, if you have a function, let's say that you have a function a that takes a string and then a string and then a string, let's say, just for simple, and then you have b, which takes a string and produces a string. Okay. Now I'm comparing to Haskell because the function application is the same as in Bash. So let's say we have like echo, or no, we call A, okay, we have like hello, but then we call B, we say B here, and then yo. Okay, well, the types doesn't really match up because this is like, but what, let's say you have like this, I don't know, something here. How would you parse this now? So basically, A would probably take these as arguments, but how this is gonna get called now is like we parse A, and that this would be a string literal, right? But if everything is like a function call, then this would be an argument to this function. But this function doesn't have any arguments, so we don't parse any arguments to this function though. But when we get here, this is actually a function call now. So this would take over and take all the rest of the arguments. This is how it happens now. But in Haskell, what's happening is that it will take like all of the arguments here is gonna try to put into A until A runs out of arguments. So it's gonna, since it has 2 arguments, it's gonna take these 2 as arguments, but this is the wrong type. But then these 2 are gonna be sort of supplied to the result of this. So yeah, but that's how it works in Haskell, because Haskell is like curried, so you can potentially, this is a valid expression here, which produces this function. Because you supply this, and then it's a partial application. I'm just trying to figure out how to do it in this language. But I don't, yeah. So basically in this language, you would do, you would have a function A takes nothing, no, yeah, takes nothing, A, no arg, it could, yeah, argument arg1, arg2, and then it would produce a string yeah, and then it has some kind of expression, and then you have B, which takes 1 argument, and if you call A hello, B yo something else, now I mean, it would be cool if we could, it makes sense kind of that B would take 1 argument, but we really don't know that at this point. We don't know what this identifier type is at this point, so we can't parse it to just take 1 argument. This is going to get parsed, it's going to get this, and then B is going to take over here. But maybe we want to have a special expression parser now that like doesn't, that we ban function calls, perhaps. It could also just be an error. Like it just could be like, okay, you can't really have this. So what you would have to do is this, right? So you would get like, let's say like A tries to consume a bunch of expressions as arguments. This is an argument. This, now this becomes the next argument, which could be confusing. Maybe. I mean, yeah, I could potentially see some issues with this. But you know, this is confusing already from the start. Like, what is actually happening here? Like, A is trying to, like, what arguments goes into A? Like, it is confusing from the start. So you would probably want to do something like this. Like, I think what's going to happen is if you do this, you will get a type error saying that, hey, B doesn't take 2 arguments. So there is going to be, you know, a check that does this. But let's say they both, well, if they both take one argument, that this is also going to be an issue because, you know, this is the first argument, this is the second argument. Actually, this would kind of work if, yeah, this would work actually, because A takes 2 arguments now, this is the second argument. But it wouldn't work if A took 3 arguments and then you try to provide this, because this this is provided to B and not A. So there you would have to do this. Okay, I guess it's fine then. I guess it's fine. You want some ideas to explore and start building? What is your, like, what have you built so far? I create a Redis, like multi-threaded using Rust for my comment. Ah, cool. Please suggest some valuable projects resume oriented. I mean, I would just say do something that you're interested in, because that's how you will, you know, pursue it and build something. You know, that's how you would not, you know, if you build something and you're bored of it, you won't really succeed. I don't think in the same way. So find something that you find is fun and try to build that. No, you don't have to apologize. But what would you like to build yourself? Like, think about what do you find interesting to build? Like, what are you learning right now that you feel like? Are you actively studying programming right now, or what's? Have you built any projects before, or? Okay, if we have a parenthesis, we just so that would be the function call. I don't think we'll ever get here. Well, because we're parsing an expression, right? No, if we're parsing a binary, what would we say? If we get an identifier, we're gonna try to parse, like, parentheses is an expression anyway. Yeah, then we don't really need a case for parentheses, I don't think. I don't think we really need this. Maybe? Or, because potentially a function call this could be the callee, right? But it feels like we're kind of trapped in a circle of dependency, maybe. I think function calls should be part of the binary expression. Like that just makes sense, because it kind of prevents the whole. It has to have like a precedence. Yeah, it just makes sense. But then it's like, okay, well, how do we know it's a function call and not just the end of the binary expression? I guess we know if it's an end if we reach a terminator. So the operator could either be any of these or just a white space, and then you get the next expression. So actually, if it's not one of these, we're gonna treat it as, if it's not one of these and it's not a terminator and all this, we are going to treat it as a function application operation. Okay. But the issue there is that functions here are not really curried. And then we would have to build that whole thing as well. Oh, man. You made an extension called UniFetch. Okay, so what does that do? Cool. Well, then you have made something. MCA student working as junior web dev. So you're all working. So you're already working. So what's the issue? No, okay, that's great, man. All right. Man, how should we do this? Okay, maybe it's the job of the evaluator later to take like binary operations and like combine them into a function call, perhaps, because I really want to have the function call part of this system here. It makes sense. Or the function, like apply argument to a function call, to a function. But what would be the issue here though? Like, yeah, because the whole thing is like, okay, well, first we try to parse a function call. It's really, okay, well, it's really gonna be like, what has more precedence, a function call or a binary expression? I think a binary expression would have more precedence. So you try to call binary expression first. The issue though is that when we reach an identifier and we try to parse it as a function call. No, yeah, we could parse it. We could just try to parse it as a function call, I guess. Right in here. Yeah. Okay, sure. Let's try that. So because at first I was thinking like this should be part of the main like parse expression thing, but really it should. I'm just gonna put it in parse, maybe a binary expression. Okay, sure. So, well, okay, well, but then we have another issue though. This, okay, we need to make a new here. Is function expression terminator. Function is call expression terminator. So basically the issue here is that this would just basically parse a list, parse expression. This parse expression will also parse binary expressions. So, okay, well, we could make a special. Actually, that doesn't work because this will still consume the whole thing. So basically, if you have hello this plus this, what's gonna happen is that first we have function call, okay? Then we try to read the next argument, which is this. However, in the process of that, since we're parsing any expression, we're parsing the whole thing as a binary expression. And then if you have, you know, more arguments over here, like kind of this would make sense as a one argument, and then this would be its own expression. So this would be a binary expression, and it's kind of weird. And then this would be the next argument, but I think this will be like a parsing error right now, at least, because we're looking at exterminators or terminators. If we don't find a terminator, we're like failing here. Man, there's so many things going on here. You want to improve? That's great. Just keep working, and I mean, yeah, just if you have time over or and energy, and if you want, I'm gonna suggest just try to find something that you like, that you, some kind of project that you feel like is interesting. Start working on that and see where it leads. Like, even if you fail, like, or fail quote unquote, like, even if it doesn't go anywhere, you still have gained experience, and you still have, like, you know, you've learned something. How much is completed? Yesterday I kind of said 30%, but you know, that's just, you know, I have no idea. So I know kind of where I want to be, but we're a little bit ways away from that right now. And then from there you could also potentially, you know, explore a lot of things. But right now I'm trying to work with the functions. The functions are like the most important thing in here. So okay, I made this little MVP thing, but it's very bare bones right now, so I'm gonna fix it later. But basically, oh, what the hell is this? I changed a bunch of stuff. Anyway, I'm trying to have this MVP, which is basically, hey, we have this bash script. Anything we're trying to do in the bash script, we're trying to mimic in here. And then I'm gonna check the results of both of these in, like, you know, calling both and then checking the results. But the features that I want to have, I'm gonna just add here and then try to mimic in my language. But right now it's kind of bare bones, as you can see. So, because we don't really have a lot of other things that you can do, basically. Whoops. Hey, hello, Day309. What's up? What strategy are you using for parsing? So it's like the way it's set up right now is basically trying to consume tokens. I mean, okay. I'm used to using like parser combinatorics or whatever it's called, like when you have, you know, sequences, choices, a bunch of stuff, and you compose them into different things. This works a little bit differently. This is like the first time I'm doing this style, which is where like we just check what the next token is and we decide from there what to do, basically. But I'm kind of combining the strategies as well here. So I do have a snapshot functionality, which you can take a snapshot and restore the parser back to that thing, which is kind of like a try parse as well. If this failed, then we just roll back and try something else. But yeah, I'm really like, this is the most advanced parser that I've built, and yeah, I really need to work out some of these issues here. And it's also, it doesn't really help with this kind of syntax as well. Like, it would be easier, of course, if you could just have parentheses separated these by commas. Now this would be a super easy syntax to parse. However, that's not how it works. Like, this is how it's supposed to be, and then it's like, okay, well, how do we parse this? That's what I'm trying to figure out. Do you have experience with DSLs? Do you mean like making them, or like it's? I haven't made any languages before. This is like the first kind of toy, like more advanced, I guess you could say, toy language that I'm making. A Pratt parser. Well, I've seen people talk about that. I don't really know what it means. I read an article and I've seen some code, but I can't really tell you if I'm using a pret parser approach right now or not. I'm just trying to make it work right now. I tried to make a compiled language that had that compiled to like a generic language. I don't think I've made so many like DSLs. It would be cool though to try and it's like every time I tried to think about stuff like that, like let's say I want to make a language for a game engine that works with ESS, for example, and you have like entities, components, systems, or something like that. But then it's like, okay, well, it still feels kind of like making a full-on generic language. So it's still like a very daunting thing. But maybe you should start with something smaller, I guess. But this one is really fun. Because I was like, hey, let's just make a bash like. It should be easy, right? It's not. It depends on, I guess it depends on what bar you're setting for yourself as well. But you would basically assign a priority to each token and carry around a value. It checks the current priority. The next token is less important to finish the expression, otherwise you eat more tokens. Oh, I see. Thank you. You're the first person that could actually like formulate it in a way that I kind of understand, I guess. Thank you. Okay. I saw something about that in the code and I was like, what is happening here? I didn't really understand. But okay, that explains things like basically the theory. If the next token is less important. So each token has an innate precedence? Or is it based on context? I feel like DSLs should be used for something niche, yeah. I agree. Technically is every operator. Okay. Well, okay, that is kind of what I'm doing with this, the binary expression. However, how this works is that I create a list of components that is basically you have expression, operator, expression, operator, expression, operator, expression, operator. And that is put into a flat list of binary components, and then we work out from that list a bunch of binary expressions, and depending on precedence, which is happening. So here we kind of build the whole thing, and then we do parse binary expressions. So this is basically, well, it's kind of a weird name, but it takes the list of components, which is like, you know, you can have identifier plus identifier, or identifier plus literal plus something else times something, and so on. And then we just call, this is like a recursive here. So first we'll check, okay, do we only have one thing in the component? Then it's just the component itself, basically. If we have three things, it means we have one component, like one expression, an operator, and an expression. So the first thing in the list is an expression, so we take that as the left-hand side, operator, right-hand side. And that is the result of this. If we have more than that, we are going into this thing here, which we look for the lowest precedence of the operators, and we're using that as a guidance here. Man, when I'm explaining this, it's like way more complicated than I thought in my mind. But basically, we're gonna go through the entire list and group them by these lowest precedence operators as being delimiters. So it's kind of like a split. We're splitting the list with the lowest precedence operator as the delimiter. Okay, so then we get a bunch of groups, which we then recursively call the same functional. So in the end, we will end up with a bunch of binary expressions that are correctly, you know, precedence thing. So basically, it's kind of, this is kind of my version, I guess, of that, but it's not really, you know, you couldn't call this Pratt parsing. This is more like my version of parsing a binary expression with precedence. And I guess you could potentially use this for the whole thing. You could probably use this for the whole goddamn program. I'm just gonna refill my coffee. I'll be right back. I mean, maybe I'll just rewrite everything into a Pratt parser. Maybe that's easier. I don't know. Yeah. So but this is very generic. Like this works for all kinds of binary expressions. The only issue right now is basically the function call doesn't really have an operator. And I don't want to end up with a function call. I want to basically flatten. I guess maybe we could, because okay, if we made function calls into binary expression, you would have like a, so function, and you take like a, b, c. Okay, this will be turned into f of a of b of c, right? So this would be like 3 binary expressions like this, and that would work. But then I want to flatten this back, because this is like the tokenized. These are the token stream, and then we're turning it into a binary tree expression, and then, or not a tree, but well, I guess it's a tree. It's a binary tree, and then we turn it into a flat list of ABC back again. But now we have a function call, and this is what I want to end up with, because I don't want to have to separately evaluate this and then evaluate this and then evaluate this. Basically, if we're gonna have this, we're gonna need to have some kind of partial application construct, which we don't really have right now. But if we could make it into this, then we don't really need it. We could just have like a function call with the arguments there, which is a lot easier to handle, because we don't have partial application here. But we might have in the future, though. We might have partial application in the future, and then we might change this actually. But yeah, this could work. Like if we could take this binary expression, we could check if this expression is flattenable. Yeah, we could take a binary expression and check if we can flatten it actually into another expression, question mark. I wonder how that would work. Like, let's say we're done with this, and then we're doing this, and then we're checking, okay, can we flatten this binary expression into another expression? Can we, and then we do the same thing here. Yeah, that works. Because then we can do, as soon as we have 2 components like this, we would check, okay, can we flatten it? Okay. So basically what I'm thinking is like flatten binary expression. So we have like the left hand side, or well, we have the binary expression. I'm gonna take it as an expression so that we get the you can pass in like the binary and then we can get the field parent pointer. I'm just gonna pass it in as an expression and assume it's a binary. And then this would return another expression, which would be the result of the binary flattening happening. And so first we'll check, we get the left, binary left, and we get the right. And we'll switch on the operator. If the operator is a function call, or I guess apply, which we don't really have right now, but let's imagine, then we can potentially do a well, this is a okay, this is a binary operation. We can turn it into a call expression. Yes, so we turn it into a call expression. So if we have apply, we turn this into a call expression. I mean, we could also just make it directly into a call expression, but okay, well, let's just do this. So but then it's like, okay, wait, it's apply, so this will be applied to that. I guess we have to check. No, we just take left is the callee and this is the argument. But then we have to flatten it the next time. We have to check, okay, if this is an apply, then we take it out and we add the b to the argument list. Okay. Right, so if we have an apply, first we need to check if the left is an apply as well. Or wait, no, not apply, if it's a call, that's right. And if it is, then we will return a new, then we can flatten it. So then we return a new thing, which will be a call callee is call.callee arguments is going to be, so now we need to like concat span is going to be called span ends at right span. And that. Okay, and then the concat this is gonna be, oh yeah, you need a type. Oh, you need type after. Interesting. I think that's not common. Like usually the type is first. Did they change this? Or is it just for concats? I don't know. Anyway. Okay, so this would be, or am I just tripping? I don't know. So this would be, well, it's just gonna be yeah, it's gonna be expressions, right? Pointers to expressions. And then we have the list of slices. So this is gonna be, first we have call arguments. So that's the first list. So because we're just appending the thing onto there. And then the next one is gonna be well, it's just gonna be right, the right as a one argument. So we kind of, yeah, appending that on there. And then we have to defer call the initialize, or, well, but where does the, no. Well, okay, it doesn't matter. I don't think we should deinitialize it because it's in the arena, so it doesn't really do anything anyway. Okay. I like, you know, you're kind of seeing these things a lot in Zig. Now we could make, you know, another function and stuff, but whatever. It's just, it's not really a big deal. So basically we're checking, okay, do we have an apply? So then we can actually flatten it. If we don't have an apply, we just return the binary back. Okay. Now if we have an apply and the left hand side was a call already, we merge the calls. So we merge this call with the apply here. And then, well, then we're done. But if we have something else, we will just return the binary, because then the left hand side is not a call. It's actually, in this case, we're dealing with kind of the first thing, the first expression, I guess. Actually, we could remove a bunch of these. We could say return here. We could say return here, or not even return. We could do that. Let's see, this is the outer switch else, this is the inner switch else. What am I missing here? Oh, there we go. Okay, we removed a little bit of nesting there. Okay, and thank you Heroic Shield for following. Thank you, Dumb Guy Codes, if that was you. Okay, so we're kind of, yeah, we're flattening the binary expression. It only handles, you know, calls right now, but that's the, yeah, that's the only flattening thing that we have. So basically, yeah, this should work, right? So now we can actually parse, you know, function application as a binary operation, include it in our thing, and it will properly have precedence and everything. So let's augment this with apply, which doesn't really, it doesn't have a token variant, and also apply should be like the strongest binding. So I'm gonna say 0 there. Alright, cool. Right. Now, as I said, we don't really have a token version of the binding, like the apply thing. So what we need to do is we need to here, when we're checking for an operator, we're checking if first we're checking like, do we have any of the actual operators? Otherwise, do we have a terminator? We break. If it's a range, there's kind of a special case here, then we break. But otherwise there's like an error, so then we abort the whole thing. But if we get here, we should be looking at a function call actually. So I'm just gonna remove this and say that we will append we're using like this allocator. Okay. We're gonna append also next is not, yeah, that's just peaked. So we don't consume that. We just change the mode into reading expression mode or component mode. So we have a spanned binary operation, and the payload is gonna be, so we don't really have a token for this. This is kind of weird. I guess we'll just I guess we could just take the next token, span. So the payload is apply, and the span is next span, because that's what we are applying. We could also take like the thing in between, I guess. Technically, that's the thing, but whatever. It doesn't really matter. I don't think I'm even gonna look at this, to be honest. This span here of the operator. Okay, and then let's see what's happening then. Then it goes through, it consumes the token, but we shouldn't do that, so we should actually just continue here. And with the continue expression, I think it advances the state, so that will take it from this is like, you know, this is not the correct name. I started out with an arithmetic expression parser, but now I made it into a binary, so that's why it said arithmetic there. Arithmetic, sorry. And then this will basically toggle the state between expression and operator as we move along. And then depending on the state, we're either reading an expression or an operator. And if we get something weird, we are trying to read the next expression. Okay. Let's hope that this doesn't mess up a whole bunch of stuff. So now basically we should have the apply operator as well. And that should now automatically be part of the system. So we should get a bunch of binary expressions that has the apply operator, and then we flatten them. Well, we are not calling this function though, so we have to call this function whenever we produce a thing here. We have to flatten it as well, because this is going to produce an expression, but it's also okay. Well, I guess we could use this one. So if we have, let's say what's happening here. It's an identifier literal expression operator. Right, that's the component type, right? And toExpression just makes it into an expression. So either we have expression, we have literal, identifier, operator. Okay, yeah. And then this would actually always, so yeah, so we shouldn't do this on operators. But this could potentially, like the expression could potentially be, well, this couldn't be, I guess this wouldn't be a binary expression. This wouldn't be a binary expression. But this could. So I think here we call, if we call flatten on this one, flatten would be called on basically everything. Where is this? Oh, this is like a special case. If we only have one item. But that should already be done here, so we don't really need to do that actually. If we, okay, we have a special case actually if we have one item and the thing is an identifier, we escape, because then we need to parse it as a pipeline, but that's actually not the case anymore. So I think we can just remove this and only look for this case. If we don't have any items, we will abort here, or yeah, we will try something else. But this should work now. And we flatten that. So this is actually what we want to try and flatten, I guess, maybe. And this one. Yeah, we have to do both. Actually, we don't really need to allocate a new expression. We can just, I mean, we have the thing already. We can just deal with these. Yeah. So, okay, but when do we actually create the call, the first call? Because if we don't have a call, nothing will happen, basically. We have to create the first call as well. Because this only happens if we already have a call. But where's the call created? We have to have a starting point for the call. So basically, if we have apply, but the left-hand side is not a call, then we should like create a call actually. We should create, we can't just return the apply directly back. We should create the call here. So this would be the call actually. Okay, and then we have like callee is the left hand side. Wait, we're switching on the left hand side actually. Yeah, that's fine. And then arguments would just be right, but we need to allocate this. So I'm just gonna do dupe. And the span is going to be left span and at right span. Okay, so there's our first call. Like if we have an apply operation, and if the left hand side is not a call, then it's supposed to be the callee. So then we create the new call, and left is callee and the right is the only argument. And then if we go to the next binary operation where the left is now this call here, we would just take the arguments, append the next right on it. So that's how we flatten it there. I mean, it's probably not the most optimal solution. It's probably not like the most, you know, optimized solution, but I'm not looking for basically speed here. I'm looking for, you know, just solving the issue and trying to make it work firsthand. Okay. Now we just need to call this on something. I think we just call it on these things here that we return. So flatten, I guess try self flatten binary. And actually, now that we're working with expressions, we can just we can actually just say that this is a binary and returns a binary. So we don't actually. No, actually, we don't return a binary. We return an expression. Right. Okay. Fine. There we go. And I have to call it down here as well. Now. Okay. Wow. All right. Okay. So I think we have like function calls now. The one thing that I would like to check out is the parse pipeline. Now, I'm not sure if this will ever get called anymore, because the way that it was called before is basically if we didn't have a binary expression, or if the binary expression, well, if the binary expression only had one component, which was like an identifier, and that was the only thing it had. No arguments, no other operators, just one expression. Then it would kind of fail here, or it would like, yeah, it would go, you know, it would abort this return null. So then it would go ahead and try to parse a pipeline. But that won't happen now, because yeah, this would actually read it as a function call now instead. So the parse pipeline is, I think we could just delete that, to be honest. Yeah, and here, well, okay, I guess this only happens if we have a terminator next. No, I'll do this. Yeah. The dot is like a member access, so that should also be a binary expression now. And the sign is also a binary expression, but they are kind of special case handled here. And if we don't have that, we parse the pipeline. So, but we will never get here. We'll never get here. Like, this is not really maybe anymore. This is actually parse binary expression right now. So we're not really seeing this as a maybe anymore, because it will like parse everything, I think. Well, let's fix up. We need to add like dot and assign to like the binary expressions, but I'm gonna wait with that a little bit. I will add a to do here. I'll remove this to do, and I will say to do add member access and assign as binary expressions. All right. Now we'll go and see what the issue is over here. Okay, we got new binary operator, so we're evaluating a binary. if we get an apply here, it's actually going to be an error because you know, the yeah, it's an error basically. So because the issue is that we should always transform the applies into calls. It's just used as a temporary thing. So I'm gonna get these values, or actually no, I don't want to do that. I want to do like the span. It's gonna be binary span, and I want to log trace expression. Actually, we could take expression. Actually, this is the but we could do. Actually, the only thing you do with expression is take the span. So actually, we can change this into span. Let's make a separate function, and you will be span. And there we go. That's it. And then the only thing you need to do is to call log span with expression span. And now we can do log span binary span, and we'll say error encountered apply binary expression. Yeah, that is like a compiler error, so that really shouldn't happen. So this is actually going to be an error. Well, I guess we'll just follow through here. Must handle all properties. Oh yeah, and then we also have pipe, which also is gonna be unsupported right now. Okay. Now, no more errors. Let us build, and we'll go to some kind of let's do like call. Okay. So with that, now the parser has changed drastically now, so I'm not sure what will work or not, but I guess we'll try here. So let's do like echo hello. Now this will be a function call. Let us check what kind of AST we get here. So runic print AST call. We get a function call. And we don't have printing. So let's add some printing to that, so we can see more what's going on. Where's the? Well, it's not a binary actually. It's a call. Yeah. All right. So let us grab you. And then this is a call. Span. +1 will do. Actually, this will be like callee. Do we want to write that whole expression out? Like, it's actually an expression. So, well, I guess fine. Let's do, well, then we can do render expression callee and Well, let's do like 4 call arguments. Write all args and then we'll do expression argument, and then you are gonna be level +2, I think. All right. Okay, let's try that. Okay, there we go. So now we got a call, the identifier of the call. This is the callee. I guess we could include that actually. Sure. Callee +1. Yeah. So the callee, let's add another level there. All right. So the callee is the identifier echo, and then we have the arguments. So this is argument 0. I guess we could also say, you know, here actually we'll do argument. Let's do print argument, and then we'll add I here. All right, and this would be level +1, level +2. Okay, so this is the argument 0, which is a literal, it's a string, and it only has a level. There we go. So now we can actually see what's going on. So now let's try to, where did it go? Call. Yeah, let's try adding some more. And there we go. It's flattened and parsed. And if we have pipe, something else, yo, it doesn't work. Okay, so let's log parser 1. Okay, so it fails at the pipe for some reason. Consume statement terminator. Okay, so we're starting at the maybe binary inspection. We are doing this. Yes, very good. It's like it's reading the components. And that's a string, yeah. And then it reads this, which it should read as an operator. Oh, did I forget to add that to the operator list? Yeah, probably. We should really just add all the binary operators in a list instead. Yeah, I forgot to add it here. There we go. Oh, now we get some other issue here. Interesting. So we got here, we should read that, shouldn't happen. Oh, from token pipe is not. No, that's the literal. Okay, we need to add the pipe, which is gonna be a pipe. There we go. There we go. All right, so now we can see everything worked here. So we have an expression statement, which is a call. The call is identify echo. We have argument 0, argument 1. Actually, where's the pipe at? Argument 1 is an operation pipe. Okay, that doesn't make sense. Wait, should the pipe be lower? Okay, the pipe should be lower precedence than the function operator then. Wait, did I do this the wrong way? No, pipe should be very strong. Wait, apply should be the strong, even stronger. Okay, or they apply. Yeah, the apply should be the strongest. There we go. Now we have one binary, which operator is pipe. Let's bring up the example so we can see the code here. So this is the left-hand side and this is the right-hand side. So now it works. So we have a pipe operation here. This pipes into this. The left-hand side is a call with these things, 2 arguments. And the right-hand side is the callee, something else. So hey, it works. Okay, well that was actually, you know, not so bloody actually. Cool. Oh, what's going on? Okay. What do we do now? I guess, well, we can't really evaluate the pipelines. That's the thing. Like, if we go to evaluator, and the pipelines, they are now basically not supported anymore. But they are parsed. Yeah, I'm just gonna think about this a little bit. I'll be right back. I have to do something here. All right, let's continue. So, okay, so how it works right now is basically we have a pipeline expression, or how it worked like before, I guess I should say. So we had a pipeline expression, which is just evaluate pipeline, right? So the pipeline is this. So basically you have a bunch of stages and then a span. But this is kind of like, it's very rigid sort of construct, I would say. It doesn't really make sense for us to have this anymore. And then each stage is like kind of weird. It has like a role. This is all AI slop here. Like it has a role, command, expression. Like it doesn't really make a bunch of sense. And then we have like a stage payload, which is also command or expression. I'm not really sure why we couldn't just use the tag here instead of having a role, you know. And then you have command invocation, and here is like a function application actually, with arguments, and for some reason we pass environment assignments here as well, which is kind of strange because that should be part of like the context. And then we have like redirects. So the idea would be to, I guess, try to parse the redirects beforehand and then encapsulate it into the thing. And then potential captures for you know, catching errors, or well, yeah, or optional values and stuff like that, which are not entirely, it's not entirely thought out yet exactly how it would work, but I just know that I want to simplify this a lot and not have this kind of weird structure here. Like, sure, it encapsulates a lot of stuff you need in order to kind of execute an executable, but I don't want to do it in this form here. So this is how it worked before. Like you had these bunch of stages, and then they would be passed down into an executor, which would like run all those things. But it won't really work like that anymore, I don't think, but I am not 100% sure exactly how I want it to work actually, because if they are supposed to be like binary operations, then I mean, let's say we have, let's do some examples. So let's say we have like, you know, the super easy example. This is not really a pipeline actually, so this won't really be a pipeline. This will be a just a function call actually, which will result in some kind of, you know, it will result in like a stream, and yeah, and that's just going to be put out to the context outside. So actually we could probably actually do that right now, to be honest. If we go to call, now we don't have pipe, so I'm gonna do this, but this should work potentially. Like this should be callable. Wait, not AST. Okay, it's unsupported expression. Where do we get that? Oh, type checker. Okay, well, let's skip the type checker. Okay, now we get unsupported expression in the execution. Now what is that? That comes from here, of course. It's just unsupported. Okay. Oh, it's just, okay, we haven't implemented the actual function call expression. Okay. But I just find that it's so much easier to think about what this will be now. Instead of thinking about the whole pipeline, we kind of break it out into components and then just figure out how to compose them. So we should have a call now. That's why it fell through to this. but now we should handle it. So evaluate call. All right. Evaluate call expression. All right. So what do we have? We have a callee, which should be a function, and then we have a bunch of arguments. Now this could be an executable, which it is in this case. So let's just try to evaluate the callee. Now, what's this gonna happen here is that since this is just an identifier in this case, yes, I am back. Since this is just an identifier here, this will kind of try to evaluate this as an identifier. Now, the current like how that works is that we evaluate that. We're trying to do a lookup, but then it fails with unknown identifier since we don't have an echo identifier in the like there's no built-in or anything like that. It just fails. So basically, if that fails, we should treat it as an executable in this case. I'm probably gonna add some safety stuff for those kinds of things later, like having maybe you have to type like this, or you can say echo equals something like this, and then you can use echo as in your program, just to add safety railings to make sure that we know what we're calling. But for now, I'm not sure if I'm gonna do it. But for now, I'm just gonna say that, hey, this is gonna be an executable, and we're gonna treat it as one. So instead of doing try here, we have to do catch, and then we do switch on the error. And if the error is, also I need to add breadcrumbs here. Oh, we don't have it here either. There we go. Okay. Now, if we have an error that's called something invalid, no, identifier something, what was it called? Unknown identifier. Wait, is that even part of the thing? Yes, it is. Okay. So, unknown identifier. Then, now I believe we can actually do this now. Then, we will treat it as an executable. Well, okay. Well, the problem is though we don't really get. Well, if it's an unknown identifier error in the process of calling this expression, we don't know if this is the actual identifier here. We kind of have to. Actually, we kind of have to build it into the program that, or in the evaluation part, that if we don't find the identifier, we're gonna treat it as an executable actually, which is kind of weird because that will treat like typos as executables. Yeah, so that wouldn't really work very well, but I guess that's how we have to do it right now to fix this here. Because you could potentially have something like this, you know? Except this would kind of call echo in here. It's not a reference to echo. It's calling echo with 0 arguments, actually. Okay, I see. So in order to have a call with this would have to be a function. Yeah. Add safety for unknown identifiers as executables. Explicit executables. Okay. So basically I'm gonna do that. Old or before unknown. Okay, whatever. I'm gonna call it backup. Just so I don't have to type it again. Okay, and then so if we don't find it, we are going to create basically a new value that is gonna be a function basically. Do we have function values actually? Yes, we do. Yeah, we do. Okay. So it's a function ref. Actually, this would be this. We have to call like init here. What is the issue? No, this would be put here. Yeah. I just want formatting. I just want to get the thing. Okay. Oh, I see. We don't. It doesn't know the type. Well, this is supposed to be a value. And then we clone it. We should only clone it if. Okay, let's do this. Let's do return here actually, because we should only clone it if we actually get the lookup here. Otherwise, we just return a new thing here. Do you work now? Okay, there we go. And the value... Wait, what? Oh, yeah. So this here is going to be the function declaration, I think. And it's a function ref inner. So it's a function declaration and closure. Oh yeah, that's right. But we don't really need a closure. The executables doesn't have a closure. Actually. So this would be like function declaration is... Oh shit, we don't have a function declaration. Ooh, what would that be? Okay, we'll put something here. Closure is going to be null. I'm not sure what this is going to be. It's going to be something like... executable function declaration, and then I guess this would just be the identifier name. So we'd have to like create it somehow. We have to create a function declaration on the fly for this name, which is going to be used to be able to call the function, right? Or we could change this type to be a union enum. Let's just do this. So executable function declaration. Okay, create executable. Let's do that. We don't need scope. We don't have this. We just have an well, we just have a name actually. Maybe. And then this would return a function declaration. But you need a pointer, right? Right. Hello, Coffee. What's up? Chat rules explaining. What are you on about? Just one question? Ah, sure. How are you? I'm doing great. Thank you very much. How are you doing? Right. So this needs to be a pointer. So actually, let's just return a pointer here. Why not? All right. So let's do function declaration is allocator create function declaration, and then we return that. But we need to fill it with something. So we will have try as well, and you will be error. So you would be okay. So we do have a name. Now the name could actually, okay, we could actually do like identifier here and get the identifier itself. Copy that in there. That's fine. And then we have span is going to be, I guess it's just a span of the identifier. And I wonder if we could just do init here. Actually, let's do this instead. Let's do like that. And name is identifier. All right, LAN going well? Yeah, I think so. It's fun, fun process. Is it interpreted? It's interpreted. Is Zig good? Hey, I thought you said only one question. No, just kidding. Zig is very good. Very, very good. It's very good. I do code in C, sometimes Rust. I didn't code in Zig. You should try it to get yourself an opinion. But I personally think it's very good. I haven't. I have coded in C++ a long time ago, but I have never coded in C. I've seen a lot of C and read some C and stuff, but never done like a project or anything in C. And I've never really did anything in Rust either. I'm building another extension that works without a server, which will translate and transcribe lively. Sound from Chrome tab. Without any server, which will translate and transcribe. How do you do that? It sounds like you're gonna use like AI or something. Also, it sounds very ambitious if you're gonna do it without a server. You're live somewhere else too? Yes, I'm live. But Twitch is like the main, I guess. Well, it doesn't really matter. I'm using the transcribe and translate model. From local file, it will work. Okay, okay. That's good. I think Twitch has better delay on chat though. So I think that's why I like Twitch chat more. But you know, what do you mean? Like local file, transcribe and translate. So you're analyzing the sound and transcribing and translating, or what? How do you do that? What are you using to do that? Okay, what else do we have in this thing? I'm just gonna copy all this, put it here. Alright, so this is false. Params is empty. Well, it's really not empty. Actually, params is kind of weird because params is like, now we need to support variadic parameters, which we don't really do at this point. But yeah, I'm gonna have to fix that. Standard in type. Oh yeah, that's right. So this is like an optional stream of strings. But I'm gonna say no for now. But really, this should be set this to up to something like this. And this one is the return type is also, well, yeah, the return type. We don't really use the return type. That's the thing, I don't think, right now. But this is also gonna be kind of like, yeah, an optional stream of strings that can fail with a byte error. Actually, it could fail even though this is, I guess it could fail like in the spawn process. Maybe we should always treat it as a stream of strings then. We could do this. If we need to add this here, because it could fail at spawning the thing, but we could still create a stream that failed in that case, so we don't really need to do that. Okay. And then the body is a function body, which right now is supposed to be, well, it's only expressions right now. So I think I will just change this right now. This is supposed to be only expressions. Yeah. There we go. And now we can just do this. Oops. Body is body. Alright, now you are not a switch, you are just append expression body. Same thing here. Oh, that's just gonna be the body. There we go. Oh. Okay. Well, we got one here as well. We don't need to do that. Well, we could do body, I guess. All right. There we go. All right. Back to here. So, you need identifier, so we'll pass that in there. All right. And of course, we need to try. Okay, so the only thing left is the body right now. Well, and the params, I guess. So the body needs to be some kind of expression that will be called, of course. And what is the expression? I feel like we're running around in loops now. But we do have a way to turn a executable into a function, which is good. So then when we encounter the function, it's just gonna get called, and then the expression will be evaluated. But the expression that we have, what is that expression is going to be? What is this expression going to be? Well, it's gonna spawn up the child process, I guess. And then, yeah, we have to do all that whole thing now. We get audio live and translate and transcribe it. I'm building so I can watch Japanese streams and don't have subtitles. Whisper Wasm. Onyx models. But that's an AI. I asked you if you were using... Yeah, okay, so you have it like stored locally. But how big is that? How big is the model? Hello, Discordianism. Yes, I'm still going at it. All right. Yeah, okay, so we're kind of moving the problem before us here. Basically, here is that we need to have like an execution expression. And we don't really have that right now. So we need to create it. I'm just thinking about how it should be. The parameters also need to be like variadic. It needs to be something that can receive parameters. It's kind of like a function declaration, except it's going to be like a command type thing. Maybe then body would be like a union enum. Actually, now that I think about it, I'm just gonna copy this and then have this as a command or executable expression. Name, we don't really need the name. We already have like a function declaration that will call this with an already known name. So really, this itself doesn't have name, it doesn't have parameters. What does it have actually? I guess it doesn't really have anything. It only has like a span, result type, I'm just gonna return null for this right now. Alright, executable doesn't do anything. Right, okay. So then this would be, do we have parser here? No. Do we have an arena? No, we don't. I don't think this is part of an arena. Where is the evaluator created? Here. Allocator is passed in. And that's just this allocator. Okay. So I think what we want to do is we want to create an arena in the evaluator that we can use for these kinds of things. So I'm gonna add this arena. I'm gonna name it something like loose ends arena or something. Just to make it like, we're not supposed to use it for everything, just for things that gets like allocated like this. And that we don't have any way to kind of go back and deallocate right now, at least. Okay, so then loose ends arena is gonna be init allocator. And then we have deinitialize. Wait, where is deinitialize? What? We don't have deinitialize. Okay. Do you have the initialize? All right. Okay. So we'll do body is going to be Lucent's arena allocator create expression, and then we'll populate it with something. Yeah, it's just going to be an executable. An executable has a span, and the span is identifier span. And you will be body. Oh, there we go. Now it works. Okay, so now we have this executable expression, but we don't really do anything with it. But we can at least get to it now. The params also need to be upgraded. Like right now, it's just a list of parameters, but really, we need this to be kind of like a union enum now. So I'm gonna call this parameters, and I guess we can put it here. No, it's a union enum. So either we're gonna have how do you call it, like variadic versus what's the non-variadic term? Okay, non-variadic, I guess. Variadic. Constantatic. Yeah. Variadic, and then it's gonna have some kind of you know, type expression. I guess potentially you could have like a bunch of non-variadic. You could have a mix as well, like you have a couple of parameters that are required, and then you have a bunch of optional as well, like, you know, function A, B, and then the rest. But let's start with just the one thing. If we had currying, that would be easier to implement. But this will be good there. So variadic, actually, will it be easy to implement? If you have currying, how would variadic work? I'm not sure. But anyway, this just needs to be like a type expression or something. It would just be like, yeah, it would just be the type of the actual things that you need to put in here. It could also be like a tuple type, maybe. No, that doesn't work. Then it's not variadic. Yeah, it just needs to be like the type of the things that you put in here. Or we could just force it to be strings. Now, let's just do a type expression. All right. I'm putting optional there because of type inference. Okay, so that is now parameters. And parameter types. Okay, so this is the type of the functions. That also needs to change. This needs to change as well. No. And the reason I put underscore there is so that I can say this non-variadic, and we get this in here, which would be this type. So that the name of the function is what we can use. Actually, this has to be underscore now. Let's just put that there, why not? And you would be this. Why does that look like a type now? Okay, there we go. And I will basically put this over here as well. Okay. Yeah, and then this would just be switch on parents if it's non-variadic. We get parents here, and we do all that. Pretty sure you can shadow like that. Variadic. Actually, non-variadic. And this will be variadic. And then I guess we have to know the type. So this would be the type expression function parameters. There we go. Oh. Oh yeah, variadic. There we go. Yeah. Format. So I guess we'll do switch. Is like where's the issue? Oh. Okay. Now we have a bunch of issues. Let's start with the parser. Right, so we don't really have support. I don't think we're gonna have support for variadic functions right now, like creating your own. It's basically gonna be only for the executables. It's kind of like Zig with the C interface. This is like Runic with executable interface. So we only have parameters, right? So basically this is going to be non-variadic. No? Where's the function? Why do I not get the function here? Is it not public? Is this public? Okay. All right. And then you are the thing. Why is this an issue? A list of parameters. Oops. Parse parameter. Oh. Wait, no, that's different. Yeah, okay. But wait. Function declaration. Oh, parameter. No, but the variadic. Okay, this is also supposed to be a parameter. I guess this is also like a parameter. Yeah, okay. Yeah. This is a parameter. And this is wrong as well. This is. There we go. All right, now we actually need to go and look at the type here. Yeah. Okay. There we go. All right. Okay. Then we have evaluator, type checker. Type checker. I mean, sure. Let's just switch. And we'll basically do the same thing, except for this parameter only. Yeah. But the type is different. The type is actually going to be like a... Well, maybe we embed the type in... yeah, it depends on when we parse it, I guess. We'll just add a thing in there. Okay, now we have this part. Okay, now we're back here. So now we can just say variadic. Again, why don't I get the function? Okay, but we get the variadic. Oh, maybe it's because it's the wrong... No, it's not the wrong thing. And we need a parameter. So I'm just gonna say args or parameter create that as a union in. Okay. Yeah, this is gonna be identifier and the name is gonna be dupe args. Actually, you know what? We're not ever gonna deinitialize this anyway, I don't think. Well, okay, let's just do it anyway. I was like, yeah, it could just be a constant actually, but let's just dupe it for safety, I guess. Span is gonna be there is no span for this. Okay, I'm just gonna say it's identifier span, fine. All right. So that's the pattern. Type annotation is gonna be oh yeah, parameter type. And we're gonna create a type expression. Now this one is a union enum. It should be, it's gonna be an array. Of some other type expression, which is a string. So I'm just gonna create that here. Actually, I think it's a literal. No? Well, we don't have a string. Oh yeah, we don't have a string. It's an array of bytes. That's right. Oh, so this, well, okay. So the string type is an array of bytes. We also need to create here. And you are a byte. There we go. And then you are an array of element strings type. All right. All that for the parameter types, or the parameter. No, wait. Yes, the parameter type. That's you. Okay. The default value, I guess, would be the empty. Well, it's null actually. And then mutable is, I mean, it doesn't matter since we're not controlling it. Span is span. Okay, so that is our parameters. Well, that is our one parameter. Okay. Now we could make these types as well, but we don't have the stream type right now. So, okay. That is our thing for that. What is this? Expected that, found this. Oh, variadic. There we go. Okay. Now we do try here instead. So now we should actually get the thing. Like if the callee, if it's like an unknown identifier, it will automatically be a an executable right now. Okay, so now we just need to call it. So we have the callee. We need to kind of evaluate all the arguments, I think. So this would be like callee, no, call arguments. Yeah, so arguments. So arguments is gonna be allocator, create, or allocate. And this is gonna be values. We're gonna get a bunch of values. Actually, we could create an array, actually. Nah. I don't know. We'll see. So we'll create this, I mean, array, like a value array, not like a zig array. And this would be call argument length. All right, and then we loop through args, and we'll keep track of the identif or the index. We get arg I, and then we'll say arg. Actually, let's do pointer there. And you are also, no, you're a slice. But now we can say arg is equal to call arguments I. That's an expression, so we have to do try self-evaluate expression. Right, so that will give us a value out. So now args is basically, it's a bunch of values, right? And then we will also here defer, we will not try, or free args, all right, and here, so if one of them is an error, we have to kind of clean up the rest. I think what we do is we defer here, we loop through arguments, and we deinitialize each argument. Yeah, we have to do that anyway, so, and we free this list as well. So that's good, because if any of these fails, arguments would have had. Actually, you know what? We have to know how many failed. Actually, let's make an array list instead. Array list of values, and we can init capacity to arguments length. Okay, yeah, that's way better, because then we can just call arguments to initialize, and we can say arguments items, because that will actually keep track of which items are actually like created here, and not go through the whole thing. Okay, and then we'll go through not args. Well, yes, args items. No, we'll not do it like that. We'll go through callee arguments. No, call arguments. God damn it. And we don't need I anymore. We don't need you as a thing. And what we do is we say args append assume capacity, where this is the item. There we go. Yes, and now in this down here we have a bunch of arguments, and we have the callee. So can we now just call the thing? All right, I'll just BRB a second here. I'll be right back. Okay, sorry about that. Now I am back. Okay. I think I have to. I may take like a food break soon and then come back. Maybe I'll just. One second here. Because I am getting a bit hangry. Actually, you know what? No, okay. I'm just gonna. 1 second here. Just ordering some food here. Okay. There we go. And I'll just take a little break when the food comes. Alright. So what do we do here? Well, basically now we have like everything we need to call this executable, right? And then we're gonna be able to like wire up the value to kind of like we're turning this executable call into a stream basically, and that's what's missing here. We need to create a stream from this executable call and return that stream as a value. So that is, now we need like the stream type. I'm pretty sure this is how we're gonna lay it down here. And then you can be able to use the stream in other ways. So we'll add the stream maybe as like a built-in type. Yeah. It's just gonna be built in because it's just such a central part of this whole thing. Now, maybe in the future it's gonna be changed into like a struct whenever we can kind of support that, maybe. But for now, I think it's just gonna be a built-in thing. And this will basically, since refs are kind of built into the streams themselves, I'm just gonna say that this is a pointer to a stream of, oh shit, it's generic. I mean, we could say stream of values. Yeah. All right. Yeah, let's just say it's a stream of values. And let's get stream in here. So we already have a stream construct, which is great. But yeah, now values can be streams as well. And now we get a whole bunch of places we need to fix. What is this? Format what? a value. Okay, well, I guess this would be just a stream. Where is this format function actually used? I'll just add these things. So it's like a little bit more obvious what's happening. Switch must handle all possibilities. And you are a clone. So basically, this would be stream. No, well, actually, we could just add a clone function on stream here. Put it up here, which will return a stream. Well, it will return this, which is a stream of t. And this will be also a stream of t. Now, how we do this is basically we will do self new ref which doesn't really do anything. Well, it creates a new ref and then we just return ourself. So it basically, you know, it's like a way of increasing the ref counter. And now we should have a thing. There we go. Okay, so that was easy, because we already had the kind of built-in or the supporting things for that. All right, so scope format value. Kind of the same thing. I'm not sure, like, it's not really. Oh, okay, I see. So this is a stream, and then we do, well, it's just gonna be the stream itself, because that's a pointer in itself. There we go. Okay, what's going on here? The evaluate member expression inner, so a stream. We're just gonna do unsupported for now. There's no member access right now on streams. Call arguments are materialize string. Okay, materialize string on a stream. Okay, right now it's just gonna be unsupported, because the stream has to kind of, I guess it could be supported if the stream is completed, but if the stream is not completed, like let's say you have something like this, you know, some kind of stream is equal to tail f server log. So this is now like a background process. So S would be a stream of string, or well, since it's a background process, I guess it's a little bit different. But anyway, if you have a stream anyway, let's say that you do this and we actually go forwards here, let's say in Magic Land, and you provide a stream in here, or you have some other kind of stream. Now we would probably try to consume the stream, and because we cannot evaluate this argument before, So we have to kind of consume the whole stream. If we're trying to materialize a stream into string, we have to kind of wait until the stream is done. But we don't really have a mechanism for that right now. Like if we get this stream, we would have like a while loop in here. You know, we would have to like consume the stream, which is not really a thing we can do right now. I guess we could actually add this as a function here. Consume consume all or take all, or and this would return a list of t's. Yeah. And then it's like while true, or yeah, while true, we get next. Well, we're gonna switch, try self next. So basically, yeah, if we get an error, we will get a stream error here. If it's okay, we have an inner while. So this is the outer while, inner while. If we get something, we will get the next value here. This is t, I guess. Well, it's an event, so we have to switch on the event. X, so it's e actually. And then we can get, like, if we're completed, then we will break outer. And we also have to create this list. So we have to have the list is an array list of t's. And we break at the end, we will return list to on slice. Get allocator. Wait, let's get the allocator here. Come on. Okay. So basically what's happening is that, well, we don't really need a while thing. This, I just added this to be able to I get, we could also make it just an if actually. Yeah, let's do that. So if we get the next thing, we will get e switch e. I mean, maybe you want to have, like, if there's an error, what do you do with the values that you got until you got the error? Do we return those? Or do we just throw them away? So what you could do is like defer list items oh, we don't really have a way to deinitialize those though. Hello NG Tantai, what's up? Welcome.
Man, okay. Maybe we just return it. Maybe we return like we return a list anyway. Like there could be an error, but we will return. Okay, let's make like take all results is a struct, and we could have an error. We could also have. Yeah, and then we have the list. Right? So this would be, instead of this would be a take all results. Because then you would have to be able to clean it up afterwards. So this one would be list equals that. So we actually have to like catch here. And then we return. Error is gonna be the error, and the list is gonna be to on slice. Okay. And then we can have the next item. We're gonna try append the item in there. Okay. And we don't have the label anymore. So basically, okay. So basically what happens is that we call next self a bunch of times until we are either have an error, which can happen here, and then we return the error and we convert this into a slice, the results that we already have, or we get either we're completed the whole thing, which means that the stream has ended, so that we can return the result, or we get a next item, which means we append it to the list. So that's what's happening here. It looks a little bit busy, but that's basically what's happening here. Now, I think later I want to change it so that it's gonna work more like an iterator, so that when you call next and there's a null, it actually means that the stream has ended. So then you can actually call while self next, and it will and it will work kind of like an iterator that is happening right now. And then we can do, like, you can have an event that will be either next or nothing, I guess, or not empty, but I don't know, it doesn't have anything yet, but it's gonna be there maybe later. However, as you can see, this kind of locks ourselves into this loop here. So if we want to have this work properly, either this is going to listen to some kind of stream that, you know, the operating system is pushing data into, like a you know, like a standard in pipe or something, or we have to kind of fork this. We kind of have to we have to run this in a separate thread. So that's going to be interesting. But basically, yeah, so if you call this, you have to make sure that the underlying stream can be able to push data here without us messing it up. Or we call this function in a thread and then wait for it to finish, basically. So I'm going to add this. Is blocking until underlying stream has ended or failed. Okay. IO, yes. Maybe it will help with the async await stuff. Should I upgrade to 0.16? I don't even know how it works. I've seen like an async or is it await, like some kind of function But you could just throw a thread, make sure there's no issues going on. Sounds easy peasy, right? Okay, so, but here we can actually, we kind of have to create a stream from the process itself. So the thing that we need to do here is like convert child spawn into stream of strings to return stream. So that's what we need to do here. No, I'm not gonna do that. And then here is like, okay, we're trying to now consume this stream, right? So basically we just, now we have to say like take all. You know what, could this actually be an error now? I guess it could be an allocation error. If that's the case, then we have more problems. I think if it's an allocation error, we return it. Yeah. Alright, so this will be try this, and no, it's not a switch actually, it's the result. Oops. I can junk their ASIC interface for easy upgrade. Ah. Yeah, I really like that approach actually. Like not making it part of the language, but making it into like a standard library. So is it an interface? Maybe I should check it out actually, the source code. Also thank you Nandu0 for following. Zig. What is this IO? Is the whole thing an interface, or what's happening here? Like the whole IO module is now an interface. Huh. Future. Okay, well, it's gonna be interesting to see when it gets like released. All right, but this will be blocking now, so that's just how it is right now. Because when we try to materialize it, it's like, yeah, that's just how it's gonna be. So now this would be a result, and I guess if we have an error. We will, I guess we return it, and we also go through the list, and since we know now that it's a value, we can go through this and initialize it. We also need to free the list, I guess. What's happening? Oh. Otherwise, or yeah, we fall through here and we will return. Well, okay, so now we need to like put these in a string. So we'll make, well, we can just return, we can do like defer. Actually, let's just do it here. We'll defer to initialize everything inside. And then here we will do like concat. Actually, these are values, right? So we have to like materialize each value itself as well. It's a value string we need to make, but that's fine. We can just, let's make an allocating writer. Now, yeah, that should be fine. We just do like dupe. Or we can take it over, I guess, with init. Yeah, sure. Oh, all right, food has arrived. I'll be right back. Yo, I'm just bringing the food here 1 second. All right. I was kind of in the middle of something here, like I was flowing here a little bit, so. But now I totally lost it, though. Oh yeah, we're doing this thing here. Okay. We will extend you with stream error. All right. Whoops. Wait, why is this? A pointer. I guess maybe it's because it's an interface. Okay, yeah. Anyway, okay. So basically, okay, so we consume the whole stream. We will also deinitialize the individual values that we get. We at the end we create an allocating writer so we can write the things. We will check if we got an error. Actually, I guess we can put you down here. So we check if we got an error, then we will free. Oh, we don't want to free it first though, and then do this. That's kind of. Wait, and then this is. Yeah. Actually, we'll put. Okay. Actually, want to free it. Anyway, yeah. Okay. So first, if something goes wrong, or at the end of this, we will free the list and everything, every value in it. If there's an error, we just return the error. Otherwise, we try to build up this string here. So the result is now this is the allocating writer. So what? And then at the end, we will create a string value. Actually, that's a string ref. We have to do like string equals that, I think. There we go. Yeah, because this is a string. Wait. Oh, okay. So it is the string, not the value. Okay, sure. So then we create the new string here with the allocator and what's ever written in there. Which will take it over, I'm pretty sure. Yeah. And then, so now the only thing remaining is going through all the values and writing them into here. So we have to go through the stream result list. And we get the value out. And now we have to call materialize string again to get this here. Right. So now we should have a value string again for each of these values that we then also deinitialize at the end. And then we will do result writer write all well, this is the ref, I guess. and then the string is actually ref get. So now we get this. Now we got the string, and we just write it there. Okay. But this is basically, you could also put this in. Did you check the Twitch? What? What's happening in Twitch? I don't see anything. You read chat, perhaps, or just ghost us? Can you hear me now, or? I'm back. I was away to get the food. Are you creating a write function? Yeah, so this function that I'm in right now, this whole materialize string, is basically in the language, every expression is basically turned into a value, which can be anything. It can be an integer or a string or a float or anything, really. A stream. So this function's job is to try to turn it into a string. It's basically like string coercion. And you can see here that if we have a string, we just return this kind of the string itself. If we have a boolean, we will create a new string with 1 or 0 depending on the boolean value, and so on. If we have a stream, we're trying to consume the stream, and then all the items are values, so they will also be, we now have to kind of recursively call materialize string on the values to get a string out that we can then append into our main, like this result here. So we're going through all the items that we got from the string list, and we're appending them to this result. And then we return the result here as a whole string. I think we're done with that part. Maybe. Oh. Let's actually get the allocator. Well, we have... no, let's use self allocator. Or, well, stream. Let's do stream allocator, because it should be like the same kind of error. So now we have the stream allocator. So actually, let's just use that there, because that could potentially be a different allocator. Hopefully not. This shadows, okay. So this is like the item string, whatever. Item string ref. The initialize. Okay. Let's just put that. Wait. Oh, it's not a try, actually. Okay, yeah, good. You need to be a var. All right. So I think that is done. We do have a thing here. You sent me a link. Okay. I cannot see it. I don't see a link. Where did you put it? In Twitch? Or do you mean on Discord? Where did you send it? I'll check. All right. Okay, now I see. Okay, on Discord. Okay, sorry. I wasn't on online. Neko script. Interesting, okay. Lightweight scripting framework engine for C# game developers. Allow you to define and run custom commands with ease, making your game logic more flexible and modular. Okay, cool. Oh, excuse me. Oh, you gave up? Yeah, sorry, I wasn't online on Discord, so I didn't see it. Okay. Awesome. You made everything there by hand, or? I just need to take a bite here. There we go. Can you see it? All right. Okay. Yeah, I usually have it like in the description, but I haven't added it to this kind of series. Thank you. Yeah. All right. So let's see. This is a const. Well, what the hell? Where is this coming from? It's up here. There we go. That was weird. Like, why did it go to the... Oh, maybe I have like caps lock on or something. Of course, this is a try. Oh. Okay, let's change to an RC error. Because that's also pretty... a lot of errors. Okay. Evaluate expression. Right, you need scopes as well. Okay, now we just need to be able to convert this into a stream of strings. So what's gonna happen is basically we're gonna try to yeah, we're gonna spawn the thing. So let's go over to executor because we're already kind of doing it here, but I will kind of change how this works. So yeah, the code for doing it is in here, but it kind of works with like a bunch of different things. So where are we? Well, wait, is it even in here? Run stage. No? Wait, no, it's a command runner. That's right, command runner. There we go. So here's like run stage, run executable. So basically the thing that happens in here, we have to do as well. So yeah, it's a lot of things happening in here. But I'll basically, let's copy this and see how far we'll get. Because I think I'm just gonna remove the command executor, to be honest. So yeah, this would be the call execution. Now the thing is, right, we have to kind of check what the call is, I guess. Like if it's an executable, wait, it's a value? Oh yeah, it's a function. It has to be like a function ref. Yeah. It's gonna be a function ref. So we have to say switch callee. Are you a pointer or no? No. So this has to be like a function ref. Not sure what we called it. I think that's the case. No? Just function. Okay. Function. So this is our function ref. Okay. The Nightbot. What is the Nightbot? Hello, Flawless. Crazy syntax. It's just Zig. It's Zig. It's the best language in the world. Now, yeah, it gets a little bit getting used to. Yo, penguin. All right, I'm just gonna take another bite.
Yeah, I'm trying to multitask here. I was just so hungry before, and I ordered food, and I got the food, and now it's here, and I'm eating it a little bit at a time. I'm trying to get it out of the way so I can focus a little bit more, but yeah. You know, the time spent eating is also... The brain is working, it's... In the meantime... Okay, so function ref. Now we can check. Oh yeah. We need to get like the function, the thing underneath. I'm gonna call this function. Let's get the pointer just to be safe. All right. Yeah. We have a closure, which shouldn't exist on like executables, but we don't know here if it's an executable or not. We just know that we're trying to call some kind of function, right? But we don't know if it's an executable or what it is. So, but we're actually just treating it as a normal function. So basically, the function has a body that we need to evaluate, right? It has parameters that we should apply. So how it works is we already kind of have this. We have like run function, and the way it works right now is we run the function, we're pushing a bunch of frames. These are used for running the function, running the function instructions in the correct context. And so basically what's happening, because a function reference has its own kind of closure context, and it's not supposed to have the context that you're like calling it in. So the function body needs to be executed in a separate context. So that's why we're adding a blocking context here, which will kind of block all access to the outer context, which we'll remove later. And then we have this ref special thing, which is, you know, kind of a stupid thing. It's basically just a patch up to be able to add the closure in as a thing. Okay, so we have the blocking, we have the closure. So now we're kind of ready to run the frame, or I mean the function body, except we also add a new scope as well, so that the function can have like local variables that doesn't collide with the outer scope and stuff like that. Okay. So that is our three kind of things that we are having when we run a function. And then it basically, here we're going through, this is like the recursive thing. So we're declaring on the scopes, on the function scope, we're declaring the function itself in there, so it can call itself. So this makes it being able to call itself recursively. And then we have like a timestamp started at, and then we evaluate the expression, which is the body of the function, and we deinitialize it. Yeah, because we don't do anything with the kind of return type of the function. I think this is where we should change things now. I think. I'm still not 100% sure what's going to happen here.
I think how we're gonna work with streams is that we have like a stream capturing context. And this is kind of what the forwarding contexts are. But they only capture like the standard out, standard in, as you know, the pipes, like the operating system pipes. But we are supposed to be able to support typed pipes basically, so we need our own construct there to be able to do that. So basically this value, I mean, it's probably gonna be what is the result of the function call, but I'm still not 100% sure exactly how this is gonna get wired up. Because it's like if you call the function without binding it the result to something, then the result of the function is just gonna get streamed out into the outer context. But if you have a binding, the binding will provide its own context that will put the results, everything into the binding itself, into some identifier in the scope. Yes. Okay, how... I'm just going through this so that we can see if okay, could we just reuse this function? Maybe we can, maybe we can't. Flawless? I have no thoughts on that. I haven't seen it, and I've not followed anything regarding that. I know what it's I've heard some stuff in the beginning, like when it first, but I don't know. I just don't really care that much, to be honest. I don't wanna make gross sounds. All right. What's the to do? It's called, I guess. Still need parse and HT3. Our own language thing, or what is finished at NS? NS is nanoseconds. It's a very tiny amount of seconds. And that is what the like operating systems are working with now. Nanosecond timestamps. It's kind of crazy. Man, there's like this bridge between like a function call, like the execution itself. The whole execution itself can potentially stream out values into the outer context. Like that is the return value of the function, not the final expression evaluation itself. But then it's also like, what is the expression then? Like, it makes sense that you can bind something into a context. Like when you bind something, it creates a context. But when you just call a function by itself, you don't really have that. It's kind of forwarded to the outer context. So the function itself doesn't really have a return result in that sense, unless you bind it or pipe it into something else, I guess. It's like kind of like a different way of thinking about things. But that's basically how bash works. Like you call echo, it will echo out to standard out. If you don't pipe it into something else, it will echo to standard out, right? But if you pipe it, it will actually echo. And if you have a function, it also has its own context and so on. And so, yeah, it's very interesting, like the kind of like forwarding of the values that get put, that get like the data that gets put out by the expressions. Basically an expression could potentially output something, I guess. It's like this, like let's say you have a function, you know, that takes nothing in, and we have like, I don't know, 5, and then it takes no arguments, but it puts an int out. So this is like a stream of ints. This is the result of this, right? And then you can just have a bunch of 5s in here, 5 5s, and that is the stream. Like the stream is 5 5s that just gets put on there, and then you can consume it. So when you call the function, you get a stream that outputs 5 5s, and you're done. And I mean, you can also, I mean, potentially also, of course, you can put it in a a list like this. Like this would also be, could be like this is like converted into a stream. It's coerced into a stream of 5 ints as well. Like this is just an array, so that works as well. But it's just like an array. I mean, it's kind of like, and this is a block. So a block and array is kind of the same thing. It's just that the block has a different parsing. It parses differently. But a block is basically, it's just an array of expressions. So a block and an array is basically the same thing in that sense. It's just that the block has different syntax. It's actually the exact same thing. But it's handled differently. It's like the block is turned into like a process context right now, or a process handle with potential output. But an array is basically, it's also the same thing. It could potentially, because you know, you can have an array that outputs things in here. This array now has an expression that outputs things, and we can bind this into something, and that will now echo hello as well into it. So that's the same thing, and this is the same thing here. That's exactly the same thing. The result is the same. That's very interesting to me. And it means basically we can treat blocks as arrays. We could just make a block into an array and, you know, feed it into the same pipeline basically. I mean, it could either be, you could either say everything is a block or everything is an array. It's the same thing basically. I'm saying that the block and array is basically the same thing in this language right now. And that's probably how it's gonna be. Alright, see ya, Coffee. You should post videos, will boost your channel more. Yeah, I just don't have the time to do that. I know I should post by like a bunch of shorts, or you know. I just don't have the time for that right now. It takes time. I mean, I know there's like, I think there's like a maybe even like an automated way you can post like short clips of the stream or something. I don't know. All right. I'm just trying to make sense of the language a little bit. I'm just trying to figure out, like, because it still doesn't feel complete, you know, the whole idea. But it's starting to get through a little bit. Yeah, so here is basically we run the function actually. So we run the function, we don't care about the value. And that's the ref. Yeah. If the call is anything else than a function, this doesn't work. This doesn't make sense. Yeah, it's not 1 byte. I was lying. Like I'm eating a slice of pizza. Alright, this is gonna be some kind of execution error. Unsupported call expression. Or something, I don't know. Unsupported callee. Oh my god, excuse me. Now, it's kind of interesting as well, like the actual act of running the function is putting forward the return value, so to speak, into the outer context. We don't actually get a value that we need to do anything with here. It's just a return, like a run function result. And if there's like an error, we have to kind of bubble that up as well, I guess. Should that also be forwarded? I guess it should. It's like we're working with this context more and more. Like things are like more working, like it's become like more context dependent, I guess. And that's fine. Alright, so this is the result, but basically, as you can see here, there's basically nothing here. We don't really care about this result. So I'm just gonna leave it. And this expects some kind of value because we're evaluating the call expression. And yeah. I mean, I guess it would be the return type of the function. Like, let's say you're executing, you know, hello. You know, you're executing this. And this would like result in a stream, right? So it results in a stream of strings with an error maybe. And but then that's gonna get forwarded out to the context. But that's already handled. It feels like it's already done. But then we need to know if we need the value or not. Like if we need this to be a string of streams to be bound to something. But then we already have that. So I don't think we need to do anything here. We don't need to return a value at all. Actually, when we call an expression. That's kind of the weird thing here. It's like we don't actually return this because the kind of context are already, it's already like doing the things we need to do. What? Something wrong with the syntax somewhere? I'm scanning with my eyes. Something here? No. Oh, I'm stupid. It's this function that I just, you know, pasted in here from another module. Of course, it's gonna complain. All right. Now, right. So the call expression actually doesn't have a result by itself, which is very interesting. Yeah. So, I mean, I guess we could return a void or something. Or shouldn't it just be, it should be a stream. Oh man, I'm going in circles with this one. Because the stream is already connected. That's the thing. The stream is already connected. Like, we don't need to return a value. If you bind it, it's already connected to the bind. Yeah, okay, so we don't do anything with this. Yeah. We just return... actually... Right, so it does... We need a value of some sort. I guess we just have a void value then. Yeah, a void value. That's fine. Okay, let's return a value. And we'll... Whoops. Return void. It's so strange. It's like, because it feels like you're calling a function, you should get a return value, which is the stream. But then it's like, well, that's not how the values get, like, it's not like we have a stream object that we connect to or anything. It's like it's already happening with the context. It's so weird, this execution model here. But I guess, yeah, I just have to get in the mindset of this. Okay, so we call this, we get some kind of error. Fair enough. attempt to use a null value. Oh, the closure. Oh, yeah. The closure is. Oh, yeah, that's right. So. Oh, but we should be able to support like null closures. We don't have a closure, so. But then. It's gonna be weird here. It's when we create the executable function declaration. The closure here. I mean, we could make a closure. Let's just, well, it doesn't matter because the closure is like, it doesn't really matter. But we could just make it like an empty scope stack or something. Then we need to create it as well. Now let's just, I guess we'll just support closures or empty closures. If we have a closure, we will use it here. And this is like, how many frames do we have? If this is null, then it's gonna be 2, else 3. Alright, there we go. Alright, you do that. See you later. Value with count time only. Content. Okay, we got leaks. Unsupported expression. Echo, hello. Right, I see. It is the, yeah, it's the what you call it, the executable expression. So executable. No, it's in this file. Executable. Somewhere. Wait. Evaluate expression. Okay, yeah. So we have the else here. I think maybe we want to have this explicit actually, so that we can catch it beforehand. Evaluate executable. Now the scopes doesn't really make sense here, but I guess we'll add it anyway. No. Well, actually, it does matter because of the execution context. And what if we did this? Well, we get some errors for that. Switch must handle all possibilities. So what are all the possibilities that we don't have? Assignment? No, we have that. I guess we'll just do this because the LSP doesn't really help us here. No, let's do that, and then Okay, now we should get a whole bunch of duplicates. Well, array, we have map. I don't think so. Range. Member. Index. What the hell is index? We don't have unary. We do have binary. We have block. We don't have you. We have you. Don't have you. Try. We don't have catch. We don't have import. We do have assignment. We do have executable. We should have. Alright, so now whenever we add a new one, it should show up here. Alright. No field or blah, 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 blah. Yeah. So evaluate executable. Guess we can call it expression. As with everything else. Executable. All right. Now, this will basically be what we're doing in here. So let's copy this. And I guess, how do we forward the parameters and everything to this thing? We could do it with the context. I just realized. Because we don't even have a name here. So the executable expression is basically the body of the function of the thing we're trying to execute. So we should have like an executable context in the frames that we will have to use, I think, to be able to call this executable. It's kind of like context-based execution instead. It reminds me of the React contexts in web development. I just have to BRB one second here. Okay. Let's go. All right. So now what? Okay, let's do some top down here. So argv is gonna be get argv, get context argv, scopes. Okay, and presumably we have that. We will probably, well, that's gonna be stored there, so we don't need to free it, I don't think. And then what do we do now as well? So we have the arguments. I mean, I guess that's what we need. That's all we need, actually. Oh yeah, we also need standard in as well. Interesting. It's kind of like we're in our own little process, actually. That's more like what's happening here. So let's say standard in is also now in the context. So let's grab, I mean, I think it makes sense actually. Standard in, get context standard in. Yeah, it makes more and more sense to use these contexts. Okay, so assuming we have this, and assuming standard in is like a stream, let's say, we can now easily change standard in to be streaming if it is streaming. So this should be like a pipe, which comes from, where does this come from? It comes, I don't remember. Let's forget about this for now. Actually, I do have like popcorn. No, it comes from scopes, right? Where is that? Oh, we don't have it. Script context. No. Scope. What is it called? Oh, we don't have it, I don't think. Okay. Pipe materialized. Right, it's gonna be pipe materialized, I think, yeah. But we don't really need it to be, yeah, this is gonna be a pipe materialized, yeah. So we're gonna be able to check if it's streaming or not. Like if it's not streaming, we will just consume it fully and then pass it in, I guess. Perhaps. I guess it doesn't really matter. Like if it's supposed to be kind of like our own streaming context. We don't really care if it's streaming or not. We just use the whatever interface is currently on it to use. Yeah. All right. So we create our child process, or we initialize it. It's not right. I don't think it's running yet. It has to. Yeah. We have to spawn it first, and then we set up a bunch of options on it here. So we have standard in. I guess this could be optional. So let's say if standard in is not equal to null, we pipe it, otherwise we ignore. Okay, and standard out, standard error is always piped. I guess potentially here we could also sync it depending on the context. Yeah, so the context could say like, okay, well, either we pipe it, or let's say we know that standard out of the context is actually gonna be not the thing. Should we add like writers instead? You know what, let's play around with this thing here. Let's say we have standard out is a writer, get context standard out, and standard error is also a writer. Right. Now, I guess, I mean, potentially it could be optional as well. So let's actually add in that support. Like this could be optional because you could kind of pipe it into nothing, or you could bind it into nothing and then discard it. So then we don't really care about the output actually. So then we should have the same thing here. Like if standard out is not equal to null, we pipe, otherwise, I guess, ignore. Yeah, dev null. Oh, I didn't know Windows had a equivalent. Okay. Standard error. Okay. Oh, current working directory. That's true, man. I haven't thought about that. So those, okay, so are these the only things that are kind of things you can pass in as well? Because they can also be just gotten from the context. And this whole operation could be put into like wire up a child from the context. Current working directory is try self get context cd cwd, and then the end map is the same thing. So we can just pass these along here. What are you actually? An end map? A hash map? Okay, so it's a special hash map. Okay. Yeah. That's pretty simple actually. Now that you know, you lay it out like this, it's pretty simple. And we don't really need this now because we can just pass it along to the context, standard out writers. We don't need these writers. If we're passing it to, if we ignore it, we don't even get anything either. So we'll just return or remove all this. We still need this. We still need to spawn and catch and do this and that. All right, and then we kill the yeah, I'm not gonna say it, and then we defer that, and then we get the thing, and we, yeah. So here I'm thinking that the standard in is gonna be pretty simple. I will comment this out for now. And then the forward we already have, so I'm gonna remove that. And we don't care about this. And we don't really need to, well, yeah, okay, so we need to read the child standard out, but these are, if they exist, couldn't we just read them directly? Couldn't we stream them directly? Also, this needs to be like this. Same thing here, basically. If else no. Wait, could we initialize? We could just do that, right? So then we don't have to put this as a null. We don't have to worry about this being a null. We could just say that, hey, we're already done without. Right? So either we actually have the reader of the standard out, or we just have an empty buffer that's already done. So this is a reader. And then same thing here. If we have standard error, we get it. No, because this is not a pointer now. God damn it. Can we have this pointer here? This is kind of like, it depends if this is like in its own context or something, like in its own scope. Like this. No, we should be able to get this address, right? The only way this will be invalidated is that if we're in a different function, right? We should be able to do that. But it's const. No, okay, it doesn't work. Okay, let's just have the fixed writer here then. Or fixed reader. Standard out, fixed reader. You need to be a pointer, standard error, fixed reader. All right. So now these should be properly. Why does it say question mark? Oh, file reader, fixed reader. There we go. Now you are a... Wait, why is it const? God damn it. I don't think it's const actually. Why does it say const here? Like this is a var. And we get the pointer to the content if the thing, and then we get a pointer to the thing. So this is not a const. And this shouldn't be a const either because it's a var and we take the address of that. Okay, maybe it's a LSP bug or something. Let's see. Okay. So that's this whole thing here is like the readers for standard in or standard out, standarder, right? Depending on if we actually have a standard out, standarder on the child here. All right. And we have the writers, which we can just get from standard out. And really these things, well, they are writers, so we can just use them directly. Yeah, so we don't even need to have them here. And I will just remove this for now. Okay. Now what about the reader for standard in? We need a reader for standard in as well. And that comes from here, which should be the pipe materialized, which has a writer. Oh, I see. I guess we don't have support for like reader pipes. Should these be optional then? Oops. So let's have like a reader and a writer, I guess. Does it even make sense? No. Forget about this. I think that this is not. This is just a reader actually. This is just gonna be a reader here. The context standard in is going to be a reader. Yeah. Maybe. Okay. And then We already, so now we have the reader. This is the reader of the child. I guess we need a writer for the standard in then. Okay, okay. So we need a standard, so we need a child standard in writer. Yeah, because this is really like child standard out. I have to make these distinctions here to not be confusing. Okay, let's try and put this in like a struct here. So I would just do like child writer or something, and then we'll have reader, sorry. And then we'll have like the buffer. We will have the standard out or the file reader. And then we'll have the reader, which is going to be this. I will set it to undefined. Or, yeah, because it has to reference this whole thing. Yeah, and so let's do like init. We'll take a standard out. I guess this is optional as well. So this will be the, this is like a file reader. Yeah. It's kind of what we already have. Like this is just a buffer. This is actually just a buffered reader. Reader buffered. No, a buffered. Wait. Wait. How do you do it? Like child? No. I don't know. Anyway. So this will return a child reader. Buffer's undefined, reader's undefined. And then I guess we have like connect. We need to set up the reader itself. So this is going to be the address of the file reader. Yeah, this is going to be if we have a file reader. It's going to be the address of the interface. Otherwise, standard IO reader, fixed, empty buffer. Okay, so now we can say child standard out reader is going to be a child reader in it. Okay, make this var, and it's going to be child standard out, and then child standard out reader dot connect, and then that basically does everything that we're trying to do here. Except, wait. Except this is like reader. Wait, is that not a file or a file reader? Oh, it's a file. I see. Right, and then the file reader is going to be file reader streaming. Oh, we don't have the buffer, right? So we'll initialize you to null, and connect will actually set everything up. So you will be if file f, we will get reader streaming self buffer. Otherwise, this is null. Okay, there we go. So we create that with a null file. Now we have this reader. Yeah. Thank you, Piano Recorder. All right, so now we can say this. And yeah, a lot less error prone, and you don't have to repeat yourself, and it's, you know, it's not that much. We can just move this over here so we don't have to have it in the actual function itself. So basically what it is like you're creating a buffered reader, and you're inputting a optional file. So if you don't have a file, you will still get a reader, but actually this could actually return the reader. Even better. So now here we have child reader in it, and we connect, and this is actually the standard reader. Yeah, so this would be standard reader, I believe. And standard reader. There we go. So now we get this more conveniently. Yeah, and then we have the stream function, which we don't have here. So we have to go over to command runner, and we have to go to the stream function. And I'll just yank that, put it here. Now this works for any reader and writer, so it makes sense to have it like outside of the thing. It works with everything. So it's, yeah. And then, well, I guess the only thing that we could do to make this a little bit more better is to have a generic of which type you're reading, because potentially we could use this for any type, because you can read, for example, or wait, what is it called? Like, yeah, you can take a struct, for example, and then, you know, you can encode the struct into bytes. You basically take the byte representation of the struct, encode it into bytes, take it back with the reader, as long as the endian is correct. And yeah, that will make you able to read any kind of zig type, basically. Did you complete the echo? I'm working on it. I know it's like the basic building block, and I basically made it work like 1,000 times, but I feel like the thing that I'm building right now is gonna be kind of the more permanent solution to the problem here. Now you're adding file reader like Nano. I don't know about Nano, but yeah, I mean the file reader is kind of this is built in here into Zig. This thing here is like the built-in file of Zig. This is the file reader. It's also built in, and this is also the built-in interface. But the thing is that with Zig is like you have to, when you start with a file that's optional, you have to also attach a buffer that you're reading into. Well, it's good to have anyway. And then you have to make a file reader, and then when you have a file reader you have to make a reader, but they all have to be like, you know, they have to have a stable pointer as well. So if you make this into a package, it's a more easy way to turn a file into a reader, basically. So this is, well, I'm saying child reader here, it's actually more like a file reader actually, you know, now that I see it, but it's like an optional, I guess we'll call it optional file reader to make it a little bit more distinct. So basically you put in an optional file and you get out a reader out, and if it's, you know, if the file was null, the reader has like nothing in it, so it will just end immediately. But if the file had contents, now we connect it up and you get a reader out as well, and it's all buffered and everything. So yeah, that's nice. Okay, and now we have this stream function as well, so that we can like stream in whatever is available into these things here. Now, the only thing that's missing here now is that we need to also stream standard in. So standard in could get closed, I guess, as well. And then I guess we do the same thing, except standard out reader is from the child. Standard out writer is to the context. Except this is just called standard out, but it's optional, so we have to have it as well. So I guess standard out is closed if standard out is equal to null. So either, okay, either standard out is null, or, well, yeah, that's it. Or false, but that's just standard out equals null. So if standard out is null, the standard out is already closed. If standard is closed, or yeah, it's closed if that is already null. Standard in, same thing. I am in my home office, you could say. I work from home, so still learning in English. All right, well, you're doing good, pretty good. I mean, you're doing really good. Okay, so now the standard in will stream. So basically now we can do like if standard in, we will do this, and the reader would be standard in, of course, and then the writer will be, wait, the child standard in. I don't think we have that. Oh yeah, we didn't create the writer for the standard in. And I think the child standard in is also optional. Yeah, okay. So we need a writer, we need an optional writer actually as well. So let's just copy this, make this into a writer, and there we go. Reader into writer, and are we done? Do we? Is there a thing? Yeah, there is such a thing as a file writer, and we have a writer. Yeah. Basically, same thing. Writer streaming is also a thing. So, awesome. Welcome back, Dumb Guy Codes. How was the anime? Or was that someone else? Sorry, I forgot. Function parameter shadows stream. Oh. Let's see. Let's call this like forward stream or something. I don't know. Okay. Now we create the standard in file or child standard in writer. Standard in writer. Standard in writer. Cool. All right. You go into the writer there. You will do if we have standard out. We will forward standard out. We're connecting the pipes. The child standard out to the context standard out. And the same thing with standard and this would be standard I mean, we could also that's fine. All right, so this will basically loop through. I guess we will also check for if this is closed as well. I'm not sure how the behavior is here, like if we have to wait until all of them are closed. I guess standard in would be the one that closes first usually, I guess. I don't know. Anyway. Standard in, so this would be right forward stream as well. So it's nice that we can use the same function for both of these cases here, I hope. Anyway, so basically, yeah, we're waiting for standard in to close here. I guess the writer wouldn't actually close. It's the reader that would close here. Yeah, the reader. But that's the wait. Okay, now my brain is crisscrossing here. So this standard in comes from the context. So that is what has been connected from outside, I'm pretty sure. And then we're trying to push whatever comes from here into the child standard in. Yeah. And then yeah, I guess the child standard won't be like closed by itself. So it's the standard in it's our own reader that will get closed if it's when it's done. And then these are the right. Yeah, that makes sense. Like it's always the reader that closes, not the writer. It doesn't make sense. Okay. Yeah. Okay. So once we have all this and like the context and everything, this should be properly set up here. And once all the streams have closed or child has been terminated by this in some way, we then wait. So what's happening? Okay, so let's go through what's happening in this loop here, because you can see this is an infinite loop, sort of. And welcome back, Penguin. And so what's happening is basically we set up all the pipes and everything, readers and writers. And here is basically we're just waiting for the process to end, basically. But we are streaming the standard out, standard in, standard er in a streaming manner, so they all are like connected to each other. So basically we just grab whatever's available in standard in at the moment and pushes that to standard in of the process that we spawned, and then we grab whatever comes out of standard out from the process and forwards that to standard out, and the same in standard er. Now I realized that we could potentially get stuck here and not stream if it always has things to stream here. However, maybe we don't actually, because this is just gonna do it once, and if we got everything and we end the stream, then that's fine. But we still should get the data out, because end of stream shouldn't happen until, yeah, it shouldn't happen if there were things to read from the stream. Yeah, no. So basically, yeah, everything that's available, we push it forward. We will take everything available here, push it forward to the context standard out, and so on. Same for standard out. So that should just loop through everything and constantly push things forward there. And once it's done, once we detect everything is closed, we wait for, we call this, which basically will make the sub-process terminate. And yeah, we also added these error messages here because apparently in some cases when you called wait, that's where you would find out if the command existed or not. Interesting. All right. And then here's where we are finished, right? And here we're kind of gathering standard out, standard er, but we don't actually need to do that anymore. So I will actually just delete this. And the thing we want to have is probably like process ID maybe. We have started as, finished at. I mean, process ID is really not useful right now because it's already closed at this point, so this doesn't even matter. I mean, I guess for debugging purposes it could be good, but I don't think we're gonna need this, so I'll just delete this. Yeah. And then, but if we need it, we could just add it later, so it's not big a deal. And then we have like status is kind of the exit code. So this is the one thing that I haven't like implemented here yet. It's like handling errors while streaming here. So something could go wrong, and I guess that these things will close. We will get some kind of terminator signal here, and then yeah, that would be whatever we get from here. So this would be like status, like the status is a stage status, which really index doesn't really matter here, because index, it refers to the index of a pipeline, but now pipelines are actually, you know, they are binary, so you only have like up to two stages in a pipeline right now, the way it works. The thing we're interested in is the terminate signal probably. So that's actually that's actually a separate exit code, which is interesting. You kind of have two termination results in that case. Like you have like the term signal, and then you also have the exit code itself. Except if you have a term signal, do you have an exit code actually? Okay, well, I guess here's the thing for that. So yeah, so you just have this term thing. So really the exit code could actually be term instead. Because here it's kind of like, I'm doing it like this. I could augment this to add a terminator instead. Like the byte, we could add, we could change this to be the term instead. The terminator thing. Alright, thank you, Piano. Have a nice day. Have a nice whatever it is there. Evening. See you later. Okay. Yeah. I'm not gonna change it right now, but it's just gonna be for later. So these things we have. So that's fine. This thing though, I think it's just gonna be the exit code, to be honest. Exit code, yeah. No, exit code. And we're just gonna have the term there, and then we don't have standard out, standard. We don't care about that. All right, and then this is like an executable. This is like an execution. So let's just add these. Now I guess the exit code is, that could actually, that should propagate. Probably. But yeah, let's do this. Whoops. Yeah, this will change. Like this should be the same thing. Like this, yeah, this is like a, this is not gonna be there. This is just gonna be like process term, no, child term, there we go. From process, well, this is gonna be more like from term. And so we can switch on it, and if we have whatever it was called, exited, we can now check if byte is equal to 0, we return success. Otherwise, well, let's just return this. We will do term equals term. I guess it could be part of error. Yeah, this is gonna change later anyway. If we got anything else, we have the term. So basically we just change, if it happens to be exited and the byte is 0, we turn it into success. Otherwise, we're keeping the term there. Okay. Now, right, from, okay, well, let's do from process, but let's change it to from byte. And now I can say, yeah, this would just be from byte instead. Reuse that a little bit. So if we have term, should get an error code. I'm just saying at 1 for default. From term, okay, so this I will just do that. And then I'll just remove this for now. This is we're not even gonna go in this code here. Oops. No, wait. God damn it. What if we go here? Command runner, where is that used? Where is this? Okay, evaluate pipeline. You know what? Let's just remove this because we're not even gonna have this expression anymore. Well, oh. Okay. You are okay. Let's just do undefined here as well. Undefined. Okay. It's not in a great state right now. Oh my god. I'll just remove this from our site. There we go. No field name byte in term. What is this? Render code. Okay, I guess if we have exited, we get a byte. If we have anything else, what do we get? Signal stopped. Unknown. So stopped, is that like it gives itself a signal, or what does that mean? Signal feels like it's like come from outside. Unknown, I have no idea. Maybe there's like special operating systems that does something. I'm just gonna do inline else. We get some kind of signal and we'll write it out. Terminated with signal. And you know, I'm just gonna put the number there because yeah. Should we put it in hex, maybe? I don't know. Wait, it's 32, so... Should it be like this, maybe? Wait, why do I say 2? It should be 04, I think. Okay, yeah. Alright, use of undeclared args. Why is this still complaining here? God damn it. There we go. Problem solved. Okay, well, not really. Don't worry about it. Oh my god, what is this? Script context. Yeah, I don't think this is even used here. I really want to just rip this out. What is this even used for? Nothing. And you need context for what? Binding error. We don't need that. Context. Forget about it. No, we don't need these functions. Remove. Okay, good. And I'll just remove you. I don't need you anymore. There we go. Thank you. Alright. So nice. I just removed a whole bunch of AI slop basically. All right. So, now, we have a couple of things we need to work out here. You're trying to say the name here. We don't have that yet, so chill out, man. Alright? Chill out. There we go. We're just trying to say that we're trying to evaluate an executable expression. We don't have anything. These things we need to create. I mean, the executable expression doesn't really have anything in it, so yeah, I'll just get rid of that. I mean, one thing that we could do is like log the span out, but no. Anyway, now we have all these things. We need to well, first of all, let's call this function so that we can get the errors. Oh, we are calling it. Okay. Why don't we get any errors? Okay, let's restart the whole thing. There we go. Thank you. Execute options. You don't even have that anymore. Great. You. Okay, well, that should be good. You don't exist. Run with nmap. Get out of here. Where's the run function? Where's the thing? Birch runner. Yeah, let's do this instead. Right, isn't that the thing? Come on, man. Wait. No, that doesn't work. No, yeah, run pipeline. It's this function here. But we don't need this crap. We don't need this. Stop it. We don't need this run function. Yeah. I'll remove this. We don't need the command executor. We don't need any of this crap. There we go. Very nice. Executor, get the out of here. Thank you. And we don't need you. There we go. That is nice. That is nice. Alright, init with runner, get out of here. I'll just remove all this crap. Command executor. No. We don't have this. Right, execute binding. If it's a process handle, we do a bunch of stuff. So we don't care about this anymore because we don't have it anymore. You are evaluate pipelines. I will just remove you actually. There we go. Feels good. We don't have you. Get out of here. Let's just get rid of this. All right, cool. Well, now we're starting to get somewhere. This we don't really need to return anything. I'm just gonna return a void here. Yeah, the block is a void. There we go. And this is not how the functions are gonna get called anymore. Like we actually have call expressions right now. Before it was kind of weird. Like you would end up with an expression that was just a function, or yeah, it's an identifier that has the function value, so it would call it here. Now, actually, we just return this directly. Very nice. Cleaning that up. You yeah, this is not gonna work like this anymore. I'll just remove this and we'll have to figure out how this is gonna happen. No field memory. Oh, yeah. So now we're here. Okay. Get exit code. Alright. Well, we don't have you anymore, so. Basically, we'll get the exit code. That's just gonna be like if something bubbled up to the main context as it is here, then we just exit. We don't even get the code, I don't think. So I'm just gonna do this for now. Scope. Nope. There we go. Oh. Actually, let's keep it in. Just I don't want to have to do any more changes here. Okay. Immutable binding. Okay, yeah. Well, let's add this here then. Okay, there we go. Now we removed all the crap. And we got a bunch of functions we need to implement now. Now, in order to support these things, we might need to extend the context with like the scope. So basically how it works is that the execution scope, we keep this structure around, which has everything in the scope. And it's basically just a bunch of frames, and each frame can be different things. So that's the whole context basically. What is this? Main yeah. So you can also have like, if you have imported a module, it has its own scope. Stuff like that. So we have to keep some scopes around. But basically the main scope is this scope here, and you have these frames that are here as well. So you have this single frame is basically just a list of bindings. So that's basically, you know, you have your local variables, and a kind of function declaration will be in here. The scope ref is basically if you kind of want to put a whole other scope in a frame, then you can do that. This one is basically only used for closures, which is kind of the same thing as scope ref, so they are the same thing. But a little bit special use case there. And it's basically only for like memory management issues. For the context is the context that describes where the pipes go. So you have like standard out, standard er. Those are described in the forward context. So you can, if you want to redirect somewhere, you can just push a forward context and have the redirection be there. And then when another function inside this scope will push something to standard out, it would be able to grab whatever is in the current context and then push it out there. So that's what the forward context is. And then we also have the blocking, which is like it's blocking the declaration scopes, and that's mainly used for the closures, so that the closure doesn't, so the function that's executed in a closure scope doesn't go out and change things in your in the callees scope, or the caller scope, I should say, because the callees scope is the closure and the caller scope is whatever scope you call the function in. Okay, so with all that said, now we need more context here. So we have like the forward context, which has like these two things. Now the pipe info is not necessarily its own pipe, it could be inherit as well, which means that you have to like bubble up to get to the thing you need to go if you want to actually get the thing. And here's like the materialized So that is the actual pipe where you get the rider here. However, now we also need for standard in. So we need standard in, which needs a separate kind of thing here, which is a reader. And really, these should be called not pipes, but it should be called like I don't know. This should be like rider, really. I mean, or stream rider or something. Pipe rider, yeah, maybe pipe rider. This should be like riders and not readers. So this is like pipe rider materialized. And yeah, and then yeah, that's it. And then we'll basically copy this and make a reader version. And let's just do like rider. And there we go. So now we have a reader version. And standard in will basically be reader materialized. Pipe. All right. Now where's the forward context? Yeah, so this is the materialized forward context. Basically, you filled all this in, because basically what could happen is you have a bunch of these forward context, but none of them has like the actual materialized version. So what we do is we bubble up until we can populate all of these three to get the actual where we should put things. And so this one is actually, we could supply another one. This will be the reader info now. There. Okay, and now we need to create those. When we try to get those things, where is those functions? Well, here is also like we have to supply this now. Standard in, but it's like sometimes we don't have this. Maybe. Let's see how far we'll get here. But this will basically be so init forward contexts, init. Yeah. And the streaming part, I think we'll just remove that actually. That doesn't really matter anymore. I think we could just remove that later. Now here we need get standard in, just convenience. All right, and let's see. Get forward context. So here we also need now standard in, pipe reader, and I'll just add this standard out, standard in. All right. Okay, so now we have standard in, but we need some other stuff as well. We need like some kind of environment maps. Like we need like env maps. We need current working directory. Right. So basically, you know, if someone makes, that's also the thing. Like we don't have support right now for like changing the directory. Like changing directory in bash is not a command. It's a built-in shell thing. So you can't really change directories in, because current work directory, well, it is tied to the process, I believe. Perhaps. Actually, I don't know. I'm pretty sure when you spawn a child, yeah, you can supply what directory it's supposed to be spawned in. Yeah. So that should be like an operating system thing. But okay, so basically, I mean, if let's say you have a script like this, like cat file, like cd into logs, and now you cat this, right? We actually kind of need this to be a keyword or like some kind of like we could start it with it being a keyword or a special kind of function. It could actually be a function that is declared in the outermost scope, and the expression body could be a special kind of expression that changes the current working directory. Yeah. So then you could just then because then everything should work out by itself. It just changes the directory to whatever. And now we're basically, what's happening is that we're pushing this context. So here we are happy in our little context. CD will push another current working directory context. So when we're here, we are now in our new current working directory. But it's kind of weird because this is not really a sub-scope of this. It's kind of like in execution, you could kind of see that this is scope 1, and now this would be run in scope 1, but this is now run in scope 2. So everything else here is run in like the next scope. So if you see the whole bunch of times, each time you're doing this, we will add another scope. So maybe instead of adding a scope, we would modify the scope that we are in. And each time we create a new sub-scope, maybe, you know, it depends on how we want the CD to work. Like, I'm not sure how it works in Bash, but let's say you call a function which will CD somewhere. Does that affect the CW, like the current working directory of the caller as well? I mean, I know you can create a subshell, but I'm wondering how the standard works, because we probably want to have the same behavior. So I mean, let's cd. So we'll do like cat server log, because I know we have that one, and then we'll cd into source or something, and then we'll list. No, wait, we need a function. So let's make a function that will cd into source. So if we run and then do this, that will show us right. So here we can see that first we're trying to cat server log, it works. Okay. Then we run the run, it cds into source and tries to cat it, so then it doesn't work. But then we try to cat again, and now so this changes the context of the outermost shell, I guess. Like if we would run this in a sub shell like this, I don't think it will. Yeah, you can see here first, this is the first server log. Here is the error message from inside here, but now cd is kind of restored here. Now I'm not sure exactly how I'm gonna do with subshells. Like we definitely have the ability to support it right now actually, but I'm not exactly sure exactly how it's gonna work. I just know that it's not gonna be a parentheses, because this to me this is just, you know, it's not really. I mean, in a programmer language, this is, you know, this is usually just, you know, grouping an expression basically. It's not creating like a scope. It would look something more like this maybe then, and we run it in another scope, which is like a blocking scope. But again, that won't work really. So we need a kind of special kind of scope. I'm not sure exactly how it's gonna be. Like maybe you do this to make a subshell. I'm not sure. Some kind of thing is gonna happen. We're gonna have to support it one way or another. But what I'm saying is that when we cd here, we don't actually push a new scope. What we do is we change the current scope. So at the start, you would have a current working directory scope that cd will then modify. So that's how it's gonna work. But we do want a current working directory scope. Now this is just a path, so this will just be a string, I guess. However, yeah, the current working directory is like this string is supposed to just be used. Yeah, let's just do it like this and we'll see. Because it doesn't really have a way to like deinitialize itself. I guess we can have it here. Well, it could be a string ref as well, I guess. No, it's just a value string, right? Yeah. So it's a string ref. This will be, which works out actually, because when you cd into something, that itself is a string ref. So we could just ref that, and we don't need to like dupe it or anything. So this will be the string, and we'll just initialize it. There we go. Easy peasy. Right, same thing here. Log bindings, you don't really have anything, so there we go. I mean, I guess technically we could try to, we could actually log out where we are actually, so let's just print out We should really have like a format function for. Yeah, okay. We could add a format function on the ref. I'm not sure if we already have one actually. No, I don't think so. No. Okay, well, let's just add a format. And we need a writer. And yeah, it's gonna be some kind of error and void. Right, so we get like the value is self get. I'm gonna no, let's do get. If there's something wrong, we'll just, I mean, I guess we could return I guess we could do like writer write ref error or something like that. But if we did get it, we could print, and then we use the format function of the underlying type. So this would just be, you know, forwarding this, which, whoops, not printf. There we go. So yeah, so if we try to format a ref, it would go into the underlying type and try to format that if it can. Where were we? We were over here. So now if you have a string ref, we could easily just format it. And here is like current working directory is equal to format string. Now I don't need to like get the value out and do stuff like that. We can just call it directly on the ref itself. Cool. All right. Oh yeah, so after there's an error we need to return, so we don't expect the value back. Okay, what's going on here? All right, so you need standard in now. Where does this come from? Run script. Actually, this is interesting. We don't really have standard in, so I guess we'll add it here. And now you need standard in. And you need standard in. All right, here we go. Back in good old main. Let's do streaming on these actually. I'm not sure exactly what's the difference, but whatever. Scope. All right. Find in frame. That's not supported. Closure. So this is basically gonna try and copy this. Yeah, we need an init function. let's just use a string. Yeah, lookup. This will just continue. You need that. Are you shadowing? No, probably not. Okay. This thing. So if they are not null and this, okay, so this is like if we have everything. There we go. Okay. And you need standard in. Wait, where are we now? Execute binding, right. Okay, so standard in is actually now, this is actually, if we bind something, we don't have a standard in. So it actually has to be like inherited. So if we put optional there, we're gonna say if we have standard in, we get it. Otherwise, we're gonna inherit instead. Yeah. The same should really be for these two, but I don't think we have like a case where we don't supply both of them basically. Alright, so this will be null for standard in. So yeah, because in a binding you don't really have something to, we don't have anything there. Okay, now we're back here again. Okay, so we have some other stuff here as well. What's this? You, wait, you should be pipe reader. Nice. There we go. And nothing format in string. Oh, well, okay, let's go to here. And I guess we'll do like if t is equal to string or this, then we will do s. Otherwise, we'll try to do format. Alright. That should get rid of that. Okay, now we're back here. TikTok is banned in your country. Are you in USA? Where was that banned? They were trying to ban it, but I don't know if it went anywhere. Okay. argv. You know what? Okay, let's go. Let's do the scopes a little bit more generic, actually. Let's add support because argv is basically just a bunch of variables. I mean, okay, we kind of already have, to be honest, that we could just push a single frame and put a bunch of variables in there. Yeah, okay. So we can, okay, fair enough. So basically we get the context argv. Actually, we could just look up, yeah, let's just look up argv, because that is supposed to now exist. Although, let's actually put it in a function so it's more like, you know, focused here. Evaluator scope stack, and it would return a value or some kind of error. So we're just gonna look up argv and return it. Okay, well that's basically it. Well, that's a binding ref. Oh, it's not a well, it is a try. We're gonna do like error argv not defined in executable call. So now we should have it, but it's a binding ref, so we have to get the value. The binding ref. I think when we return this, do we ref it? That's always the question, isn't it? Holy shit, this function is busy. Alright, so we're kind of looking for the frame that has the thing. If we find it, we will get the value out and we'll put it in the binding ref. Okay, so we actually don't ref it here. We get the actual value. Okay, so we shouldn't deinitialize it, is what I'm trying to say. But we could clone it. Yeah, we should definitely clone it. But this binding ref itself is not a pointer or anything. It just holds. Like, what is this really? But the thing itself is a ref. What? No, that's an optional. Let's just get the value. All right, I see. I think I know. Like, if it's mutable, RC is gonna be the RC of the thing. If it's constant, it's just a value. I'm just gonna take, nothing is refed, so I'm just gonna take the value, clone it, and return that. So that, you know, we can properly take care of it later. So basically here, defer, initialize. Yeah, that makes sense. All right, that's argv. We also need to be able to push argv. So I will create a function, push argv, and we need to supply the arguments. Now I'm not sure in which form we're gonna get these arguments. It's probably just gonna be a list of things. Call. Interesting. I just realized something. We're gonna have like the effect of a of like JavaScript. In JavaScript, you could access a thing called arguments whenever a function was called. It's kind of the same thing here. We're kind of exposing in the declaration a thing called arguments, although we could potentially put it in a secret place as well. We could put so you can't access it. But I just realized that this is kind of the same thing that we're doing here, although it's called like argv. So if you have something called argv, it's gonna shadow it, but it's not really gonna be an issue though, because yeah, when you call a function, you actually bind the function parameters to their things. Yeah, it's not going to be an issue. Yeah. So basically here we call the function, we run the function, which pushes frames and things and stuff. And we got a single new thing and calling the thing. So somewhere in here we have to push like argv if it's that kind of thing. Or wait, but actually, how does bash work with this? Like, let's say we have the cd bash, right? Let's say we do run, right? So this would now, you know, do as before. But let's say we have another bash, cd2, which will, you know, cat server log I think I need to take a break here. So okay, so let's cat the server log. So what I'm thinking, like, we do bash cd sh. Now, will we still be able to do this? Let's actually remove all this. So basically, this is just cding into source, and then we try to bash it again. So how does this work? Will it be able to cat? Will this cd change the cd in here? No. Okay. So this runs in a separate thing. What if you do like this? Then it doesn't. Okay. I just wanted to know, like, I was thinking about something here, like, man, we're like at the boundary between like calling an executable, just calling a function. How do we know how to set up the executable? We have to kind of know, we have to have kind of like an expression that sets up the executable here. I guess we have the, if you have like a variadic parameter, where do we set up the parameters actually? Where's the parameters? Like here's the function thing, but where's the parameters at? Oh, it's over here. Arguments. Okay. Hang on. No, wait, no, that's not the thing. Args. Right, we're not really doing anything with the args. We need to push them into, right, okay. But when we run the function, we should have the args here, because this runs a blocking thing, so we can't really push things in here. Where does this put the arguments actually? This should have happened in here. We have the name, this is like recursive. Maybe I removed it from before. Yeah. I removed it probably. Okay, well, let's add the arguments here. Where is this from? Interpreter? No. These these are expressions. These are yeah, okay, so it's just a bunch of values, right? So it's a bunch of values that we don't need to worry about. So I think we'll put const here. Yeah. But they will get refed into their own context, I guess. Okay, whatever. Let's do that. Right, so now we'll put, I guess it will shadow its own name. So the parameters, if some parameter is called the same as the function itself, you will shadow the name of the function, right? So so right here we will do, but the thing is also, like, we need to know if we have a variadic or not. I guess we do, because we have the function ref, which has the function declaration, which describes the parameters. And if the parameters are non-variadic, we just have a list of things. If it's variadic, we have one parameter. So what we could do is we could add a function here called push function args into scope. So this would be scopes, and then I guess declare function args, and then we provide, let's provide the function declaration and then the arguments themselves. All right, so we need this function, declare function arguments, self, function declaration, arguments is a list of values. There we go. Okay, so we will basically loop, well, okay, we'll have to switch on the parameters. If we have non-variadic, we will, here we can also match the number of arguments. However, that's gonna happen in the type checker, so I don't really care about doing that right here actually. But basically parameters, okay, well, wait, yeah, you're a bunch of parameters, but the only thing we care about is how we're pushing this into the scope. So now we're just looping through, actually we should loop through these, because they have, yeah, these are the parents. So the parents should have the information about what name we should have for the parameter. So now scopes declare, and the name is going to be param. Oh yeah, we have pattern. That's right. Wait, but I think we have like declare pattern. We have like binding. Yeah, binding. No, that's not a binding. No, pattern. Bind pattern. No. I thought we had like, okay, let's go into execute binding actually. What do you do with the binding pattern? Don't you have a pattern? Yes, you do. So what do we do with the pattern? Initializer. Oh, here we go. Bind pattern. Where are you? Oh, you're not on self. You're just a thing. Okay. Okay, so we'll do bind pattern. Scopes. Pattern is parent pattern. And I guess we deref that. Mutable is false as per zig rules, and then value is gonna be well, we need to match up the number now. So actually, if they have different, now this this gonna crash here because we're gonna get an out of bounds. So that's the value there. You need to be mutable, yes, because it's gonna move it or something. So let's do that. Or I'm just gonna do like owned is args just in case. Where did it go? Owned. All right. And then, do you actually ref the value or something? I think you do. You move it. Okay, well. I guess we clone it then. Okay. Okay. Cool. Right, that's the non-variadic, and now we have the variadic as well. And we get one parameter. Now you are supposed to be like an array or something. So we have to do like bind pattern scopes pattern yeah, it's not mutable. Yeah, and this is the value, so we're gonna have some kind of value here. Okay. I'm just trying to match these patterns here. So you're gonna be a value. Right. So we're basically gonna take all the arguments, put them in one argument that is called the args, and they're gonna be an array. So we're gonna have to create a value or var here that is gonna be an array. And you are going to be a value, and here we could do we're going to do like a dupe. Value is args, options, nothing. All right, so there's our new value. Yeah, and that's just going to be put in there. So Cool. So that's our value. That's basically, yeah, an array of values. So that's what we have to deal with there. Yeah. So that's fine. Okay, yeah. So when we create the executable function declaration, actually, this is the pattern we're using. Like args is the function. We should actually call it like argv or something. And also we actually need to add the command name here. No, okay, yeah. When we actually push, okay, yeah, when we push the thing, we need to add the name actually to the parameters. Right. Push argv. No. Where's the run function? Declare args. Okay, let's just say that when we get a variadic, we also need to add the identifier of the function declaration as well. So we actually need a new, okay, we actually need to do this. We need to do like, we need to do argv, I guess. So this is we're kind of implying that this always is an argv because we don't support variadic functions in the language. It's just to be able to interface with the executables. So this would be allocator allocate values, and we're just gonna have args length +1, because the first one is gonna be the string that is like the identifier of the function. So function declaration name, but this gonna be like do this. And I have to say string here as well. Alright, so that's the first value. And then this would actually be argv now, except we don't need to dupe it, we can just use it directly. Alright, now we go through we just copy over all the args. Into argv. But now we use like I+1 equals arg. So we move them over. Should we clone them? We probably should clone them here. Yeah, we clone it. There we go. So now it's all cloned and all set up in here. So when this scope gets popped, this gets like properly deinitialized with because they're cloned, right? All right. Okay, so here now we can pass in the arguments. There we go. Okay, arguments items, and there we go. Okay, we got some cleanup to do here. Well, okay, we got the rest of these to do as well, but I'm not sure if I can. I can't really make it do that today. I will clean up a little bit more, and then I'll have to go here because I've been streaming for a while and I'm starting to feel it. Expected type value found. Error. Okay. Try. Expected array list. Wait, what? Right. So you could do like init buffer maybe. I mean, or we could just create an array list instead of values. Args plus 1. And then append assume capacity. And then we don't really need to do this. Well, we have to clone them. I forgot. Okay, but we don't need I. We can just do argv append assume capacity. All right. And now we can just pass in argv there. Expect this from easy fix. Declare function arguments. There we go. Okay, so now argv is done. We have argv. We have the name of the executable we want to run, and we also have the arguments stored in a variadic thing called the argv. Well, okay, well, it's part of the argv. It's the rest of the thing. So this should all be properly set up. This is just a, well, it's a value. We have to grab out we have to kind of grab out these strings in order to fix. Actually, let's do that right now because we're doing the argv stuff. So let's just finish off the argv stuff and then we'll continue with the other stuff next time. So how to turn it into a list of strings? Well, I guess since we do have, this is like an array of, this should be an array of, yeah, we can just assume that it's an array actually. So we get the array. Now we also get this. And actually when we get this, do we clone it? Yeah, we do. Okay, but we do deinitialize it, so that's fine. Okay, so we get this. We should get the pointer actually. So this is the, well, actually no, we don't get the pointer. That doesn't matter. So this should be the array list now. Argv list. So now this is an array list of values, and we need to create a list of strings. So we're gonna make that. So let's do argv strings is gonna be allocator in alloc list of strings, or yes, allocate a bunch of strings, and they are gonna be the argv list items length. All right, so that's our list of strings, and then we're gonna do, I just realized it's probably better to make this into an array list so that we can do defer, but let's just do it like this for now. Okay, so then we basically yeah, we just loop through items. We get argv item. Here, and that's a value. Now, what can we do with values? Well, we have a materialized string function, so we could use that. So basically, this, or I have to keep track of the index here. Oops. Right. You will be self-materialized string argv item. Now, why does it need to be a pointer though? Also, we have to try this, I think. Why do you need to put pointer? Is that really necessary? I don't think so. You don't really need to be a pointer. I'm just gonna remove that. There we go. Okay. You are the value. We send you into materialized string. What do we get out? We get out a value string. That's not what we need. We actually need, this is the string ref that we get. So what we need argv strings I equals string ref get try, and now we get the thing out there. So now we should have built our thing there. Maybe actually we will put this in here. So this would actually happen in there actually. Yeah, that makes a lot of sense. So we'll just put this in here. And do we really need to clone it then? Because we're turning it into the other thing. We don't really need to clone it actually. We'll do that. And then we'll return argv strings. You are a binding ref actually, so you will be the value there. Yeah. So you're a list of strings there. There we go. Okay, now we got our list of strings. And we don't have a dinit, so we actually need to wait. How do we deinitialize that? Okay, I didn't think about that. Maybe we should return as an array list instead and deinitialize it, so it can be like properly. No, that's just deinitializing because we're deinitializing the underlying strings need to be deinitialized. God damn it. Well, I guess we know what it is, so we can just, okay, we can defer free argv, but then we also go through each one and we free that as well. There we go. Okay, crisis averted. Man, I really want to do the rest of this, but I can't anymore. So yeah, I'll see you next time. We'll see probably on Monday. Yeah, definitely probably. So yeah, but that's gonna be it for this time. Thank you very much for watching, and I will see you later.